Good morning everyone. Welcome back on Sri Chaitanya Gosala channel, and today we are going to have a very wonderful session in which our target is that today we are going to cover the most probable problems of different topics of 11th class, and tomorrow at the same time we are going to target all the 12th class problem, which means if I talk about the branches of physics which we are going to deal today, we are going to deal with mechanics and heat and thermodynamics. Similarly, tomorrow in this type of marathon session, we are going to do the most probable problems from electrodynamics, magnetism, matter, everything will be included in that. Then optics and also the modern physics, which is said to be the most scoring part of entire physics. Okay. I hope I'm clearly audible and visible. Right. So today, good morning. Today, what we are going to do is targeting, like in the last few days of marathon on this channel, you have learned the fundamentals which are required, or you can say the pinpoint things which might be, which will be surely, in fact, I would say, helping you in order to enhance your score in the NEET exam. Okay. So today we are going to target the problems, and whenever there will be an opportunity to discuss few of the more fundamentals, I'll definitely be helping you out with that. Okay. So let us start with our problem solving session today. So the first thing is I have brought some problems in the sequence of the topics. Like first of all, we'll do some problems from units and dimensions, then kinematics, then laws of motion, work, energy, power, and so on. So according to the sequence of NCERT, we will go ahead with the problems. Okay. So the first problem is in front of us. The problem is from Vernier calipers, that is experimental physics. We all know that in units and measurements, we are expecting three problems. Problem number one is expected from Vernier caliper and screw gauge. In short, you can say experimental physics. Problem number two, dimensional analysis, and problem number three, error analysis, significant figures, and rounding off. So first few problems in order to target the one problem in the NEET exam, that is units and measurement experimental physics part. Okay dear. So let us start with that. Question says, in an experiment, the angles are required to be measured. So you are measuring the angles, but by using an instrument. 29 divisions of the main scale coincide with 30 divisions of the Vernier scale. So I'll keep collecting the information. First information is 29 main scale division are equivalent to 30 Vernier scale divisions. Okay. If the smallest division on the main scale is half a degree, which means you will say one main scale division or smallest division of main scale is called as least count of main scale. That is equal to half degree. Half degrees or 0.5 degrees. And for your information, I'll mention here that we all know 1 degree will correspond to 60 minutes and 1 minute will correspond to 60 seconds. So here 1 degree, which is corresponding to 60 minutes, can also be written as 3600 seconds. Okay, 60 into another 60. Why I am expressing it in this way? Because if you notice, few of the options are in minute and few of the options are in degree. So we must be knowing how to do the interconversion. Now what they are asking is, the smallest division on the main scale is half a degree, then determine the least count of the instrument. Means you have to determine the least count of Vernier calipers. So we know that least count of Vernier calipers is given by least count of main scale minus least count of Vernier scale. Least count of main scale can also be written as 1 main scale division minus least count of Vernier scale can also be written as 1 Vernier scale division. Now you need to only keep it in this mind, keep it in your mind that we always try to express the unknown into known. For example, here we do have the information of MSD. We don't know about VSD. So from the first information, we are going to substitute VSD into MSD. That is, 1 VSD can be written as unitary method 29 by 30 main scale division. So you can write it as 1 main scale division minus 29 by 30 main scale division, that is the value of VSD from the first equation there. So 1 minus 29 by 30 is 1 by 30 of MSD. So that can be, now you can use the information of main scale division. So the one main scale division is equivalent to half a degree, or you can say here it will be 0.5 degrees. So it is half into 60 minutes. So eventually 30 into 2, 60 and 60 will cancel, and final answer will be 1 minute. 1 minute. So the least count of this instrument is coming out as 1 minute. Understood? So while calculating the least count, see, in vernier caliper and screw gauge, only two types of questions are there. How to take the least count of vernier caliper, how to read a vernier caliper. Similarly, how to take the least count of a screw gauge and how to read a screw gauge. Okay, so we are going to discuss all type of varieties, right? Now, next, if I see, next is a problem. This is already a NEET PYQ. I have taken this problem in order to emphasize on this point that sometimes examiner deliberately forms a problem in which students only stop at the second last step. Means students have a tendency to stop here in terms of division. I would say don't ever stop at this step. The reason is, you can find out the least count of vernier caliper or any instrument in terms of division or also in terms of measurements. But if you notice, all the four options are in terms of measurements, in terms of units, not in terms of division. So how does it matter? Is this point that much important? Its importance we will understand in the upcoming problem. Okay, it's really important. So two things in mind. Number one, always prefer to express unknown into known. Very simple. That's what we have been doing since our childhood. That if we are solving a particular equation or a question, we always express the unknown into known. Number two thing, never try to stop at the extent of division till the time or until or unless all the four options are in division. Here the options are in measurement, units. So let us see how it is showing its importance here. So the next question is, the main scale of a vernier calipers has n division per centimeter. An indirect information, dear. Main scale of a vernier calipers has n divisions per centimeter. From the first line, I will say NMSD will be equal to 1 centimeters, or 1 MSD is equal to 1 by n centimeters. So whose information is known to us? Again, main scale division information is known to us. And what else? Second line of the question, n divisions of the vernier scale coincide with n minus divisions of main scale. So n VSD coincides with n minus 1 MSD. And what they are asking is the least count of vernier calipers. So the formula I am going to use the same. I will say least count of vernier caliper is 1 MSD minus 1 VSD. So 1 MSD, and let us now express the VSD into MSD. Again the same thing, unknown into known. So VSD into MSD means n minus 1 by n MSD from this step. Okay. So if you solve it further, you will get n minus n minus 1 by n MSD, and that will be n minus n will be cancelled, minus minus plus 1 by n MSD. It's already a PYQ, previous year question, and as you can see that what did you get is 1 by n MSD. So if out of the four options you see carefully, you are getting this 1 by n centimeter, and I would say this is a common mistake. Common mistake. Why that's a common mistake? The reason is that we don't see all the four options are in centimeters, means all the four options are in measurement. And here where did you stop? You have already stopped at divisions. And what I told you earlier, don't stop at the second last step of division until or unless they are not asking you all the four options in MSD or in VSD. If they are asking in centimeters or readings, you don't have to stop here, you have to get the final result there. So that will be equal to 1 by n, and now let us keep the value of 1 MSD. And 1 MSD we have already seen, that was 1 by n centimeters from here, from this step, and hence the final answer is 1 by n square centimeters. So what you were expecting here? We all were expecting option D to be your answer, but the actual answer is option 1. Alright, so that's what I said, that going forward in this session we will realize that in order to deal with every category of question, you have to have a proper mindset. NEET problems are never difficult. It's just you need to know how to solve them easily. Okay, so these were the 1-2 problems based on Vernier calipers, and I hope we have learned something, what to do and what not to do. Okay, let's talk about the next problem, and the notes will be attached in the description of the video after the live session is over, and the notes will also be shared on the Telegram group. I hope you have already joined that, but meanwhile the session is going on. If you want, you can keep taking the screenshots also. Okay, now let's talk about the next problem. The next problem is on how to take the reading or how to read a Vernier calipers. Okay, we have already learned, right, how to find out the least count. Now we will try to see how to read a Vernier caliper. So what they are telling is, the vernier of a Vernier scale is divided into 10 divisions which coincide with 9 divisions of the main scale. So first line says 10 Vernier scale division coincides with 9 main scale division. 9 main scale divisions. Okay. Each main scale division being 0.5 mm. So 1 MSD, or you can also call it least count of main scale, that is given as 0.5 mm. And are we happy with mm? Let us see the options. All the 4 options are in centimeters. So better to convert it in centimeters, that it is 0.05 centimeters. Alright. If in the final answer you need the data in centimeters, why to leave any data in terms of millimeter? Let's keep converting them side by side. Okay. So when the 2 jaws of the instrument are in contact, so the first information I have obtained from here to here, and this first information will definitely help me out to find out the least count of Vernier calipers, what I have learned in the previous 2 problems. So least count of Vernier caliper will be 1 MSD minus 1 VSD. So 1 MSD, whose information is known to us, minus VSD can be converted into MSD, that is 9 by 10 MSD, which means 1 minus 9 by 10 is 1 by 10 MSD. And I hope you will not stop here now. 1 by 10, let us keep the MSD value in terms of 0.0 in terms of centimeters, and hence the final answer is 0.005 centimeters. 0.005 centimeters. That's what you got. This is the least count of Vernier caliper. First information, first analysis. Okay, next. Now what else? We can see when the 2 jaws of the instrument are in contact. When the 2 jaws of the instrument are in contact with each other, which means no object is between the jaws. If no object is between the jaws, the only thing you can talk about is 0 error. Because if there is no object, what measurement you are going to take? Okay, no measurement you are referring to, you are actually referring to 0 error when the jaws are in contact, or when no object is placed between the jaws. So when the jaws are in contact, the 4th division of the Vernier scale coincides with a main scale division, and the 0 of the Vernier scale lies right to the 0 of the main scale. So there are 2 things. Number 1, 0 error, positive or negative, and number 2, 0 error is how much. So I will say both of them here. First thing is, next phase of the discussion is, when the 2 jaws are in contact, the 4th division of the Vernier scale coincides with the main scale division. Let me brief you regarding the main scale, which is the fixed scale, and Vernier scale, which is movable scale, and let us assume that we are moving the vernier scale towards right. So if the 0 of the main scale, which is also called as MSZ, main scale 0, coincides with 0 of the vernier scale, which is also called as vernier scale 0. So you will say no zero error, no zero correction. Okay. If both the zeros are exactly coinciding, then no zero error, no zero correction. If 0 of the vernier scale is already towards right, means already on the positive side, so zero error will be positive. Zero error is positive. And if the 0 of the vernier scale is on the negative side, okay, it has to be moving towards right only, but at the start, if it starts from 0 of the main scale, there is no zero error. If the vernier scale 0 is already right, already on the positive side, the zero error is positive. And if the vernier scale 0 is already at negative side, then you will say zero error is negative. Alright. So in the question, the 0 of the vernier scale lies right to the 0 of the main scale. If the 0 of the vernier scale lies right to the 0 of the main scale, then this is the scenario, and zero error will be equal to positive of fourth division of the vernier scale coincides. So you have to multiply this 4 with the least count of vernier calipers. So that is positive of 4 into 0.005 centimeters, which means it will be positive of 0.02 centimeters. 4 5s are 20. Alright. I hope that's clear. So that is the second phase of discussion. Third phase of discussion is actual reading. What they are telling is, when a sphere is inserted between the jaws, which means now finally you have kept the object, the 0 of the vernier scale lies slightly right to the 1.8 centimeters and the 6th vernier scale division coincides. Right to the 1.8 centimeter and 6th vernier scale division coincides. Okay, and they are asking you the diameter. So I'll draw this diagram for you. They are saying this is the main scale configuration, this is the vernier scale configuration. So 0 of the vernier scale, vernier scale 0, VSZ, lies slightly right to the 1.8 centimeter of the main scale, 1.8 centimeter of the main scale. So can I say the main scale reading is that reading over the main scale which is slightly left to the 0 of vernier scale. So dear, vernier scale 0 is lying right to something, or something is lying left to the vernier scale 0 means the same thing, which means that can be taken as MSR, main scale reading. Okay, once again, I'll write the formula for you. So I will say here, reading of diameter, vernier calipers can measure internal diameter, external diameter, as well as depth of a container. Okay, reading of the diameter is given by MSR, main scale reading, plus least count of vernier caliper into VSR, vernier scale reading, minus zero error. Main scale reading is once again that reading of the main scale which lies left to the 0 of the vernier scale. So according to the diagram, it is 1.8 centimeters and we are happy with the centimeters. Least count of vernier caliper is 0.005 there, 0.005 centimeters. Vernier scale reading is that division of the vernier scale that coincides with any division of the main scale, and that is given as 6th. Minus zero error is positive of 0.02. So I guess you will get 1.8 plus here 6, 5, 30. So it is 0.03 minus 0.02. So 0.03 minus 0.02 is 0.01. So final answer is 1.81 centimeters. Keep checking the calculations also. Okay. I hope all the phases of the discussion are clear. If you want, you can take the screenshot. So what we have learned here, how to read the vernier calipers. So if you see, in order to read the vernier caliper, we must be knowing how to find out the least count of vernier caliper. That's what we have previously learned in this session. Then we have identified that when no object is placed between the jaws or the jaws are in contact with each other, we can comment about the zero error. The entire thing about the zero error of vernier caliper is here. Very soon I'll also brief you regarding the screw gauge. Okay, things are going to be easy. Just be in a learning mode. Okay, and then the how to read the vernier caliper. Reading formula is quite similar for vernier caliper as well as the screw gauge. Just differences here, you talk about a vernier scale reading. The movable scale moves linearly, but in a screw gauge it moves in a circular way, which means instead of VSR you will be having a CSR, circular scale reading. Okay, so I hope you are comfortable with this. Let me take you towards screw gauge. Now, in a screw gauge, 5 complete rotations of the screw cause it to move a linear distance of 0.25 centimeters. 5 complete rotations and 0.25 centimeters. So first of all, I'll define pitch. Pitch is defined as the linear distance traveled in one rotation. So what I can write here is 5 rotations will correspond to 5 rotations are equal to 0.25 centimeters. This implies one rotation will be equal to, it will be 0.25 by 5, which means 0.05 centimeters. Are we happy with centimeters? See, all the 4 options are in centimeters. In the last question, we got in millimeter, but options were in centimeter. So that's why we changed. Here, we are getting it in centimeters and all the 4 options are in centimeter only. So we'll keep dealing with it directly. So the linear distance traveled in one complete rotation is commonly called as pitch. Okay. And least count of screw gauge is defined as pitch over number of divisions on circular scale. I repeat, that is pitch over number of divisions on circular scale. So the next line is there are 100 circular scale divisions. So pitch is 0.05 centimeters by number of divisions on circular scale is 100. Okay. So 2 zeros more you will insert. Okay. 0.00, 2 zeros more, 1 zero was already there and it is 0.005 centimeters. 0.005 centimeters. Is it visible there? Let me write it here only. 0.005 centimeters. Okay, that is the least count. What they are asking, so till we wanted to find out the least count, this is the first phase of discussion from here to here. Find out the pitch, that is linear distance in one complete rotation and divided by the number of divisions on circular scale. This is the way you find out the least count of screw gauge. The second phase of discussion is taking its reading. The thickness of a wire measured by this screw gauge gives a reading of 4 main scale divisions and 30 circular scale divisions. 4 main scale divisions and 30 circular scale divisions, assuming negligible zero error. And they are asking you the thickness. So I will write here reading of thickness. Reading of thickness of the wire, that will be equal to MSR plus least count of screw gauge into CSR. Instead of vernier scale reading, you will be having circular scale reading here minus zero error. So what they are telling is assuming negligible zero error. I am going to take it as 0. And then they are saying main scale reading. You wanted main scale reading, but what they have given is main scale division. So MSR, main scale reading, will be main scale division into value of one main scale division, which means least count of main scale. Can be sometimes can be taken as pitch. Can be taken as pitch, but not always. I repeat, instead of telling you the main scale reading in centimeters, they have told you the main scale division. If they have told you the main scale division, you are supposed to multiply it with the value of one main scale division. That is also called as least count of the main scale. But the least count of main scale is not separately given in the question. So in majority of the cases, you can take the pitch also as the least count of main scale. But remember, dear, it is not always valid. So when it is invalid, sir, I'll give you the problem. Don't worry. The next problem will be that where they are not taken as same. The least count of main scale cannot be taken as pitch. The next problem will be that. Okay. So main scale division is 4 and the least count of main scale, there we have obtained how much? 0.0005. I suppose you are getting it as 0.002 centimeters. Okay, 0.002 centimeters. Are we getting it the same way? 4 main scale divisions. No. I by mistake I multiplied it with the least count of screw gauge. I had to multiply it with the least count of main scale. The least count of main scale is taken as 0.05. So here it is 0.05. Okay, 4 into 0.05 centimeters. So you will be getting it as 5420. So it is 0.2 centimeters over here. So let's take it here. So that will be equal to 0.2 centimeters here. Okay, plus least count of screw gauge you have obtained 0.005 here. And what you are getting it is 30 divisions you are multiplying. 30 divisions. 30. Fine. Minus 0 error is 0. So it is 0.2 plus 5 into 3, 15, and another 0 will also be gone. I suppose it is 0.015, okay? Or else, once check it, it is 5, 3, here it will be 15, okay? 15, and it is, I mean, let me do it this way. 30 I have multiplied here, so it is 0.0, instead of 005, how many zeros were there, yaar? Okay. How many zeros were there? There were 3 zeros. I was missing them. There were 3 zeros. So during the multiplication of 1 0, you will get only 2. Okay, 1 0 will be gone. 0.005 into 3. Very easy. So it is 0.2 plus 0.015. Okay, see, 5 into 3, 15, 1 0 as it is, and hence the final answer is 0.215 centimeters. I think option D is coming for us. Okay, so this was a simple problem of how to read a screw gauge, and within the same problem I have also taught you how to calculate the least count also. So you can take the screenshot. Fine. Let us go ahead and let us talk about another problem. In this problem, the figure of the screw gauge is already given to you, and they are asking you the least count of the instrument. The accompanying diagram represents a screw gauge. In this diagram, the screw gauge is given. The circular scale is divided into 50 divisions. The circular scale is divided into 50 divisions, means number of division on circular scale is 50. Okay. And the linear scale is divided into millimeters. Least count of main scale or 1 MSD is equal to least count of main scale or 1 MSD. 1 main scale division is equal to millimeters. 1 millimeter. Okay, but this time it is not taken as the least pitch. Why? Because the question is saying if the screw advances by 1 mm when the circular scale makes 2 complete revolution. That means 2 complete revolutions will read 1 mm. This implies in 1 revolution how much linear distance you are going to travel, half mm, or since you need all the answers in mm only, it can be taken as 0.5 mm, 0.5 millimeter. This is taken as pitch. In the last question I told you that in the sometimes or in the majority of cases you can easily take the least count of the main scale to be equal to pitch. But here if you notice the least count of the main scale or the divisions of main scale, you can see those are also in millimeters, but here you have got 2 complete revolutions for that. So this is not same. You can see this time it is not going to be same. And what they are asking you here finally they are asking you the least count of screw gauge. Everyone knows the formula. It is pitch by number of divisions on circular scale. Pitch is 0.5 mm. Number of divisions on circular scale is how much it was? It was 50 divisions here. So it is 50. If you divide by that, see 0.5 by 5 is 0.1, but another 0 must be introduced because it's 50, and hence the answer I think is 0.01 mm. 0.01 mm. Okay, or that can also be written as It's like the standard Vernier caliper, 10 to the power minus 5 meters. Is that fine? So this is the way you can take the least count of the screw gauge, least count of Vernier caliper, how to read the Vernier caliper and how to read the screw gauge. You can take the screenshot if you want. Okay, and notes will also be given to you, will be attached in the description as I told you, as well as it will be shared on the Telegram group. Okay, whose link probably will be available in the description. If you want, you can click and join there. You must, in fact, because all the materials and test things will be, we'll keep sharing there. It will be helpful for your preparation. Okay, so this was about the experimental physics, and I hope and let us all wish that one similar type of problem from there, whatever we have discussed, we will directly get in the NEET exam. Type 2 problem from units and dimensions, that is dimensional analysis. Category of the problems of dimensional analysis is very easy. Still, I have taken one problem which came in the JEE mains January attempt this year, and I consider it to be highly probable for the upcoming NEET exam. So electric flux is related with linear charge density lambda and surface charge density phi as given to you like that, where alpha and beta are of appropriate dimensions, and they are asking you dimensions of beta by alpha. They are asking you dimensions of beta by alpha. So can I say, according to the principle of homogeneity, all these terms must be having the same dimension. All these terms I am highlighting, there are 3 individual terms. All these 3 terms must be having the same dimension. Principle of homogeneity ke according, what principle of homogeneity is that two types of two quantities can be added or subtracted only if they are of same type, only if they have the same dimension, and they will also obviously result into the same dimensions. Okay, that's what it is happening here. So dimensions of beta by alpha you need. So if you need the dimensions of beta by alpha, first of all, by equating the first and third term in terms of dimensions, beta can be written as phi by sigma. So that will be the dimensions of beta can be written as phi by sigma, and dimensions of alpha can be written as, in terms of dimensions, phi by lambda. Phi by lambda. Or you can also say that we could relate the dimensions of the second and third term also. So anyways, if you are going to solve it, you will get dimensions of phi will be cancelled. It is lambda by sigma. Lambda by sigma. So that is dimension of, you see, lambda is linear charge density. Linear charge density, lambda means charge per unit length. And sigma is surface charge density. Surface charge density is Q by area. Q by area. Alright. So you will get denominator will go into the numerator, and hence you will get dimension of A by L. Dimension of A by L. So area by length definitely give you the dimension of length itself. Okay. And hence the answer is displacement, because the dimension of length, area, length, breadth, height, thickness, radius, diameter, perimeter, circumference, distance, displacement, all of them will have the same dimensions. All right. So this is going to be the easy solution for this. Screenshot can be taken. Next is a body of mass. So this question deals with, it is also a JEE PYQ and previous years. So that I'm also expecting that this type of model, if not exactly the question, then this type of model can be repeated. The question is based on the rules of rounding off and significant figures. Before we talk about this problem, a quick recap. The rules of significant figures and rounding off in the calculations are that whenever the quantities are added or subtracted, the final result will be rounded off to least number of decimal places. And whenever physical quantities are multiplied or divided or any other complex algebraic operations, the final result must be rounded off to least number of significant figures. Alright. So if you see this, a body of mass is given to you, and that is moving along the x-axis with its speed is also given to you. The magnitude of its momentum, momentum P can be written as m into V, 3.513 in kgs must be multiplied with 5.00 in meters per second. So people generally start solving this question numerically. Remember guys, NEET examiner is not going to check your mathematical calculations. In your physics exam, only your physics knowledge is checked, not the mathematical part. Okay. So what is the correct way of attempting this problem? I will solve this problem or choose the correct option on the basis of rules of rounding off. So when the quantities are multiplied or divided, the final result must be rounded off to the least number of significant figures. So here how many significant figures are there? 4 significant figures. Okay. And here if the number contains a decimal point, the trailing or terminating zeros are also significant. So how many significant figures? 3 significant figures. So which one is least? 3 significant figure is least involved. Now let us check the options. How many significant figures are there here? In the first option there are 4 significant figures. In the second option there are 3 significant figures. In the third option there are 1, 2, 3, 4, 5 significant figures. And in the fourth option there are 4 significant figures again. And what is the least involved for us? The least involved for us is 3 significant figures. Hence the correct option is B. No need to even calculate it precisely. Are you getting it? So this is the appropriate way of dealing this problem, not on the basis of your calculations, but on the basis of rounding off. Okay, you can take the screenshot. All right. Chaliye, let's move on to the next one. 9765 divided 14.39 is equal to some data is given to you. This question on rounding off to 2 significant figures. Majority of cases you have to choose the final answer on the basis of rules of significant figures as per NCERT. But sometimes examiner will additionally give you the input. They will compel you that no boss, don't apply your rules. I am telling you to get me the final answer in these many significant figures. For example, this problem. Question on rounding off to 2 significant figures. If you notice there are 4 significant figures and 4 significant figures. So the final answer must also be in 4 significant figures as per the NCERT rules. But examiner is checking now your rounding off rule, not the significant figure rules. They are checking it that whether you know how to round off correctly to 2 significant figures or not. So let us start doing it. So if I see you have to round it off to 2 significant figures, so I can even check the options again here. You see how many significant figures are there? How many significant figures are there in option 1? That is 2. How many are there in option B? That is 1. Why you are not taking this 0 as significant, sir? Because trailing or terminating zeros are significant only if there is a decimal point in it. Okay. And how many significant figures here? All non-zero digits are significant. Like this. And you were asking for how many? You were asking for 2 significant figures. So obviously you will be selecting these 2 significant figures. Again, you don't have to round it off there step by step by step. See the options once. See, remember dear, NEET exam is eventually an objective exam. I have seen a lot of students, I have seen a lot of good students doing this mistake in the exam that, they find a particular problem familiar and in the excitement they start solving it, they start calculating something. But I always say the reading of question is actually completed when you also read the options. I'll put my words again in front of you. Listen to it carefully. I have a very strong opinion on this that when we say that we have completely read the problem, it must involve the reading of the options. Because options are themselves shouting that, I am the answer, I am the answer. Okay. Chalo, let's move on to the next one. Error propagation problems. Third model, which is expected from units and measurement. The density of a cube is found out by measuring its mass and length of its sides. If the maximum error in the measurement of mass and length are some given data, the maximum error in the measurement of density. So how do we write the density here? Density D can be written as mass by volume, and for a cube that can be taken as m by a cube, where a is the side length. So by error propagation rule, percentage error in D can be taken as 1 times power method, percentage error in M plus 3 times percentage error in A. So that is 1 time percentage error in mass, the percentage error in mass, be very careful. They are talking about mass and length. So 3% is in mass and 2% in its length. 3% in its mass and 2% in its length. So this is 3% plus thrice of, here it is 2%. Okay. So 3 into 1, you will get 3% here, plus 3 into 2, you will get 6% here, 6 plus 3, overall you are going to get 9%. Very simple question, power method. What we have learned separately here is, even if the quantity comes in denominator, we don't subtract the error. I repeat, errors are always added. Errors are always added and never subtracted. In more technical terms, these are the common terms. In more technical terms, you can always say errors are always propagated. Errors are always propagated and never compensated. Never compensated. One error doesn't compensate the other error. Errors always increase. Okay? You can take the screenshot. All right. Shall let's go. And it's a live session going on. So maybe right now you are in a learning mode and your friends may not know this. So from wherever you are watching this session, if you find this session productive, make sure that you share these notes and this session link to your friends, so that these are the last days here. Let's learn together and let us try to give our level best. है ना? Don't think too much about the competition. Help others also to learn in a better way. Right? Now, let's see the next problem. Calculate the focal length of a spherical mirror from the following calculations. U is given to you, V is given to you, and 1 by F is equal to 1 by V plus 1 by U. That's the mirror formula. Although that's in 12th class, but anyways here, by this time we already know it. And the error propagation is combined with the mirror formula. So basically in the old NCERT, there was a solved example on parallel resistance, on the error propagation of the parallel resistance. I'll tell you what it is. So what they did is they give you R1 resistance as R01 plus minus delta R1, and R2 resistance is R02 plus minus delta R2. Okay. And you are supposed to get the parallel formula, series also and parallel also. So series is easier. If you are writing in series combination, you can write, we know R series is equal to R1 plus R2. So true value R0 of series combination is given by R01 plus R02. Okay. And mean absolute error delta R in series can be also written as delta R1 plus delta R2, which means in series combination finding the parallel resistance thing is very easy. Why? Because the true values are also added and obviously the mean absolute errors are also added. But if you talk about the same for parallel combination, then in parallel combination it's a bit lengthier process. First thing is R0 parallel. R0 parallel will be given by R01 into R02 by R01 by R01 plus R02. Okay, that's what you do. Okay, you will get it. That's what you do, na? R1 R2 by R1 plus R2. And while finding the error, you differentiate the relation 1 by R parallel is equal to 1 by R1 plus 1 by R2. On differentiating, what you get is delta RP by R0 P square will be equal to delta R1 by R01 square plus delta R2 by R02 square. Okay. So from here, if you notice, this delta R1, delta R2, R01, R02 is given in the question, and this R0P you have obtained in the previous step. So from here, you can easily get the value of delta RP. Delta RP. Okay. So this was the solved example in the old edition NCERT. In the new edition, I think you are not getting it. So I didn't want you to, miss this model of error propagation. It is also a very important model. And the way we have a relation of this parallel 1 by Rp is equal to 1 by R1 plus 1 by R2. I call it a reciprocal relationship format. The same relation is also applicable here. So I am going to solve this particular question for you, but its reference I have taken from the NCERT itself. Okay, so the way we are going to solve it here, the same way you are supposed to solve it there. Okay, let's do it one by one. So from here they are asking you calculate the focal length. Calculate the focal length. So what I will be getting is true value f naught will be equal to u into or u naught into v naught by u naught plus v naught, r1 r2 by r1 plus r2, like that, true values. So the true value of u is 50, the true value of v is 20, 50 into 20 by 50 plus 20, alright. So that is going to be 1000 by 70 or 100 by 7, 100 by 7. So this you can find out, obviously you can easily convert it into, all the true values are different. So here though you just simplify simplify it and choose the correct one. But let us not take the too much advantage of the options. Let us see what else we could have done. If you use this relation and you differentiate it or apply the change, you will get it as delta f by f naught square will be equal to delta u by u naught square plus delta v by v naught square. Alright, let us see how to find out delta f. Delta f by f naught square, f naught you have already obtained it here, 100 by 7 and its square. Delta u is 0.5 by it is u naught square means 50 square plus delta v is 0.2 by v naught square is 20 square. After solving this, you are supposed to get the value of delta f. So if few true values, or I can say all the true values are same, suppose if all the true values are same, you are only supposed to calculate the mean absolute error to get the final answer. But here, if all the true values are different, then you could have automatically answered in the first step itself. Okay, I hope you got the final answer and you also understood what type of model I am talking about. So series combination of capacitor, series combination of spring, parallel combination of resistor, parallel combination of inductor, and mirror formula and lens formula. Series spring, series capacitor, parallel inductor, parallel resistor, mirror formula and lens formula. These 6 places are the common places where this type of rule can be applied. Alright, you can take the screenshot. Okay, now let us increase our speed a bit. Chaliye. Now we have come to the kinematic section, units and dimension, experimental physics, error analysis, everything is done. Next unit is kinematics. A particle moves along a straight line such that its displacement is given to us. The velocity when the acceleration is 0. Maximum people are in this impression ki sir, calculus based problem is not going to come in the NEET because it was not written in the syllabus anymore. But I am just suggesting you, without any calculus, without differentiation and integration, you have not done the entire syllabus here. Okay, so the graph analysis, the numerical analysis, like differentiation gives you slope, integration gives you an area. These are the things which are very common in different chapters and topics of physics. So in that hope that we will get similar problem, let us talk about it. So what they are telling is displacement is equal to t cube minus 6t square plus 3t plus 4. They are saying determine the velocity when acceleration is 0. So let's talk about the velocity and acceleration first. V is equal to ds by dt. If you differentiate, you will get it as 3t square minus 12t plus 3. And acceleration is equal to dv by dt. Once more you differentiate, you are getting it as 6t minus 12. Okay. For acceleration to be equal to 0, we have 6t minus 12. 6t minus 12 is equal to 0, which means t is equal to 2 seconds. So if they are telling you, tell me the velocity when acceleration is 0, which means they are asking you, tell me the velocity at t equals to 2. Tell me the velocity at t equals to 2, because at t equals to 2, you have the acceleration 0. So that will be equal to, from this step, you can put the value of t as 2. So 3 into 2 square minus 12 into 2 plus 3. 2 square is 4, 4 into 3, 12. 12 minus 24 is, I think, minus 12. Minus 12 plus 3 is minus 9 meter per second. Minus 9 meter per second. So that's your correct option. Alright. You can take the screenshot. This was a quick problem which gave you the transition or use of calculus in basic kinematics. Okay, we have started with the discussion of kinematics models. Next, two cars P and Q. It's already a PYQ here, NEET PYQ. In fact, there are two cars whose position is given to you, this, and they are saying at what time do they have the same velocity. At what time do they have the same velocity, which means they are telling you to equate Vp is equal to Vq. How we get the Vp, sir? Differentiate this. If you differentiate it, you will get A plus 2Bt. I hope everyone is comfortable with differentiation integration. And here if you differentiate it, you will get F minus 2T. F minus 2T. So you can take this term here and this term on this side, T term on this side and A term on this side. So you will get 2Bt plus 2T, or T if you take common, in fact 2T if you take common, you will get B plus 1, that is equal to F minus A. This implies if you are interested in finding the T, it is F minus A by twice of B plus 1. F minus A by twice of B plus 1. I think it's simple. If they want to comment about acceleration, differentiate velocity one more time on both sides. Alright, you can take the screenshot here. Chaliye. Next is the acceleration of the particle is increasing. This is the last model to show you the use of calculus in kinematics equation, but we will be using this type of approach in the remaining chapters and topics too. So the acceleration of the particle is increasing linearly. Acceleration of the particle is increasing linearly with time as bt. The particle starts from origin, and they didn't say it starts from origin at rest, from rest. No. It started from V0. The distance traveled by the particle in time t will be. So first of all, I will say acceleration A, which is actually dv by dt, that can be written as bt. So from here, dv will be equal to bt dt. If you try to integrate, you will get integration of dv and b will come outside and t dt. So when t is equal to 0, the velocity is v0, and at t equal to any random time t, the velocity will be v. So from here, what we will get is v minus v0 is equal to b t square by 2 minus 0 square by 2. So from here, v, which is dx by dt, that is equal to v0 plus bt square by 2. V0 plus bt square by 2. One phase is completed. Now, but they are not satisfied with the velocity. They were actually asking you the total distance. So from here, this dx can be written as v0 dt plus b by 2 t square dt. Again, if you will try to integrate, you will say v0 will come out and b by 2 will come out. When t is 0, the x is x initial. When t is a random time t, I think they are asking you, for a random time t, they are asking you, the x is x final. So if you are trying to integrate dx, its integration is x within limits xi to xf, so that is xf minus xi, or you can also call it d total here, and that is equal to v0, dt's integration is t within limits t minus 0 is t only, plus b by 2 t square integration is t cube by 3 minus 0 cube by 3, which simply means that is v0 t plus bt cube by 6. v0 t plus bt cube by 6, and hence the answer is, I think, option 4, v0 t plus bt cube by 6. Alright, I hope that's clear for us. Chaliye, let's move on to the next one. Okay, next is a problem based on Galileo's formula. So in motion in 1D, Galileo's formula, water tap problem, juggler problems, these are also the common models. A body freely falling from a height h describes 7h by 16 in the last second of its fall. The height h is, so if I use the Galileo's formula simply, 7h by 16 means, this is h, this is x, one part. If u equal to 0, t equals to 0, acceleration is minus g, which is constant. If these conditions are satisfied, so in the first t time, it will fall for one part, or let it be x. Let this part be x. Next will be 3x, next will be 5x, next will be 7x. If you notice, if you add them total, you will get as 16x, which means this will correspond to 1 by 16 part. This will correspond to 3 by 16 part of the total journey. This will correspond to 5 by 16 part, and this will correspond to 7 by 16 part. But sir, you are telling that the 7 by 16th part is covered in the last second. 7 by 16 in the last second. Last second means this is last 1 second. 1 second. So according to Galileo's formula, the distances will be in the ratio 1357 for equal time interval. Means this 7 by 16 part, if that has been travelled in the last 1 second, that means the previous 5 by 16 will also be travelled in 1 second, this will also be travelled in 1 second, and this will also be travelled in 1 second. So how much is the total time? 1 plus 1 plus 1 plus 1, total is 4 seconds. They are asking you the height is, therefore the total height is half gt square. Half gt square, where is ut sir? See, u was 0. U was 0, initial velocity was 0, so it is half. The g value can be taken as 10, and the total time of fall is 1111, that is 4 seconds ka square. So 4 square is 16, 16 into 10 is 160 by 2, you are going to get it as 80 meters. The twist in the story, so your correct answer right now is 80 meters, there is no doubt about it, but what if instead of saying 7h by 16 in the last second, they say 7h by 16 in the last 5 seconds. So you will say that if this part is travelled in last 5 seconds, then all the individual parts must also be taken in equal time intervals. Means 5, 5, 5, 5, the total time would have been 20. If they say the 7h by 16 is travelled in last 2 seconds, then all of the individual parts will be 2, 2, 2 and 2, and hence it will be 8 seconds, the total time. I hope that's clear. You can take the screenshot. Next, the velocity time graph of an object moving along a straight line is shown in the figure. This is again, this year means 2025 JEE Main January attempt problem, but it is so simple and too much NEET relevant. That's why I have taken it in this probable problem marathon. Okay. So the velocity time graph of an object moving along a straight line is shown in the figure. What is the distance covered by the object between t equal to 0 to t equal to 4? So in velocity time graph, t equal to 0 to t equal to 4, in this VT graph, we all know in VT curve, slope gives you the differentiation dv by dt. So that is going to give you acceleration, and area gives you integration of v dt. So that will give you, if you take the total area, that will give you the distance. If you take the net area, means above upper area positive, lower area negative, below the x-axis area or below the t-axis area you take negative, it is going to give displacement. And these distance and displacement will be same. These distance and displacement are going to be same if the entire curve is positive. If the entire graph is positive. Now if you see from here in this particular graph, when they say t equal to 0 to t equal to 4, this entire curve t equal to 0 to t equal to 4 is positive. So whether they ask distance in this particular question or they ask displacement, it doesn't matter to you. Alright. So what will be the distance here? D total, which is also this time equal to the mod of displacement because the entire curve is positive for us. That will be equal to triangle area plus it seems to be a rectangle, right? Rectangle area 10 and 2 units here, and a triangle, and both the axis v axis and t axis, minded they are also in SI units. So that's in meter per second, this is in seconds. So that is half for the triangle. Base length is 2 and the height is 10. plus for this rectangular portion it is L into B, this is 2 into 10. Alright, so this is 10 plus 20 and hence the final answer is very easy, 30. Okay, if they ask you the average speed in the entire journey from 0 to 4, if they ask average speed, although not asked this time, but if they ask average speed from 0 to 4 seconds, so I will say d total by t total, d total by t total. So total distance travelled is 30 meters. By total time taken from 0 to 4 is obviously 4 seconds here. So 30 by 4 is actually 15 by 2, which means here we'll get 7.5 meters per second. 7.5 meter per second. Alright. I think that's clear for us. So these are the things, or these are the basic questions that could be asked and repeated, like from JEE to NEET or this, that. Chaliye, you can take the screenshot and then we'll move ahead. I hope this is going fine for you. Next is very interesting question here, very interesting. It says a stone is thrown vertically upward. It's motion under gravity but not Galileo's formula. It's not release case, it's a projected case and motion in 1D, or you can also call it vertical projectile. So before talking about horizontal and oblique projectile, we are going through vertical projectile. So a stone is thrown vertically upwards with an initial velocity v0. The distance travelled in 1.5 v0 by g. 1.5 v0 by g means 3 by 2 times v0 by g, means 3 by 2 times time of ascent or time of stopping, means that will be equal to time of ascent plus time of ascent by 2, or you can also call it as time of ascent plus time of descent by 2, means only half time in the return journey. Why, sir? Because time of descent and time of ascent by symmetry are going to be same. So if I try to understand the situation is that there is a ball, suppose it is thrown with v0 at t equals to 0, and we will say it will reach somewhere here, final velocity is 0 and time will be equal to v0 by g. Okay, so you will have your journey from here to here, but then you have your journey only in half time. Half time means the ratio will be 1 by 4 and 3. Half time means 1:3. Like in return journey, I can apply the Galileo's formula if you want to do this problem easily. So I will say this is 1 by 4 of h max, and this is this part from here to here, which is yet to be travelled, is 3 by 4 h max, because according to Galileo's formula the descent is 1, 3, 5, 7 like that, and here from here to here the total distance is h max. So you can say from point A or from point A to point B, d total from A to B, d total distance travelled from A to B, that will be equal to h max while going up plus h max by 4 while going down. So you can get 5 by 4 h max. 5 by 4 h max means here it is 5 by 4 v0 square by 2g, and hence the answer is 5 by 8 v0 square by g. 5 by 8 v0 square by g. So what did we learn in this particular problem is that during the descent or during the release, so you always try to apply the Galileo's formula, but even if you are throwing an object from the ground in vertically upward direction, in its upward journey the Galileo's formula cannot be applied. Simple equations of motion and standard formula of projectile can be applied, but in return journey, because it is kind of released from the top, you can still apply the Galileo's formula in the partial journey. That's what I have done. Okay, and why I am emphasizing so much on the Galileo's formula, because that keeps the things very simple for us. Okay, and I hope you have revised your juggler model and water tap model and all those things also. Let me take an example of the water tap model here only. Water tap model. Okay, and I am taking it as a NEET PYQ of water tap model. The question was, water droplets fall from a tap at regular intervals. The tap is at a height of 5 meters from the ground in such a way that when first drop reaches the ground, the third one leaves the tap. water droplets are coming from a tap 5 meter high in regular time intervals in a such a way that when first drop reaches the ground, the third one leaves the tap. So second will be in the air. They have asked you determine the height of second drop. So the situation given is that this is the first drop that has reached the ground. The third one leaves the tap. The third one leaves the tap, and they have asked you what is the height of the second one. What is the height of the second one? H2. H2. What is the height of the second one? Because what is the height of first droplet? That is 0. What is the height of the third droplet? That is 5, because it is just coming from the tap. Okay. So what you need to determine is height of second drop. So the dealing of this problem is very easy. I would say that suppose this part is x, suppose, then the lower part by Galileo's formula is 3x. So here x plus 3x, the total part, the total journey is 5 meter. This implies 4x is equal to 5 meter, or x is equal to 1.25 meters. So the value of x is 1.25 meter, but that is not your answer, because the question was not determine x, question was determine the height. So here I will say the height of the second drop, that is equal to, from the ground, height and depths are always defined from the ground. So that is equal to 3x. So that's 3 into 1.25 meters, and hence the final answer is 3.75 meters. Is that clear? So that is also a very common model. I have just taken the reference or example from a NEET PYQ, but jugular model, water tap model, all these questions can be easily done by Galileo's formula. And this was a model which was telling you how to use the Galileo's formula in partial problem. Now you can take a screenshot. Alright, let's move on to the next one. Right. Let the angle between, so now 1-2 vector based problems, then the projectile motion. Let the angle between two non-zero vectors A and B be 120 degree and its resultant be C vector. So they are talking about 120 degree angle, and the resultant is C vector, that is supposed to be compared with A vector minus B vector. So here I'll first of all write down both of them. C vector magnitude, or C, can be written as mod of A plus B. Alright, so that is under root of A square plus B square plus 2AB, and the vector angle between them is cos 120 degrees, whose value is minus 1 by 2, and hence it will be equal to under root of A square plus B square minus AB. A square plus B square minus AB. Similarly, now if you are writing A mod A minus B, so that is under root of A square plus B square minus 2AB cos 120. Again cos 120 is minus 1 by 2. So here it is minus minus will become plus, and 2 and half will be cancelling each other, and it will be under root of A square plus B square plus AB. So see, that's a minus, that's a plus. So clearly, which one is bigger? Minus is bigger or plus is bigger? Naturally, the plus term is bigger. So here C must be greater or less, or I will say C must be less than, because these are two non-zero vectors. So plus AB minus AB term is going to be non-zero only. So C must be less than mod of A minus B, as both are non-zero. C must be less than mod of A minus B. C must be less than mod of A minus B. Okay? But sometimes, so this is a common question in which they are comparing with the magnitude or modulus of the difference of the two vectors. But suppose they comment about other 4 options. Check these 4 options. Check these options. C greater than A plus B, C less than A minus B, C equal to A plus B, C equal to A minus B. Okay, let us check these 4 options, which one is correct and which one is incorrect. So Here, what is the difference between the given 4 options and the 4 options which I have written? There you were talking about the magnitude of the difference of the vectors. But if you see, I haven't drawn any vector over here. Okay. So how to talk about this particular problem if that is modified in this way? So I will say C will be equal to under root of A square plus B square minus AB. Let's add and subtract minus AB more. Add and subtract minus AB. Why? So what I will get here is under root of A square plus B square. If you subtract, you will get it as minus 2AB, and here it is plus AB. Okay. So that is under root of A minus B ka whole square plus AB. So clearly, you know, whole square minimum value, like as you can see that you are adding something to it. If you are adding something to it, so clearly the value of C is greater than mod of A minus B. Here in terms of vector, it came out to be less than A minus B, but here it came out to be C is greater than mod of A minus B. Okay, I think I wanted to, yeah, C is greater than mod of A minus B. This is going to be your option. Alright, so the questions are very much similar, but there is a minute difference between that. Here you are comparing the magnitude of C vector with the magnitude of another vector, and here you are talking about their number data, the individual magnitude analysis you are doing over here. Alright, you must take a screenshot of this and you must revise it. Alright, okay. Chaliye, let's move on to the next one. So the position vector of a moving body, this is also this year JEE question, and which is quite probable to be repeated in the NEET, or a similar model you may have, you may see in the NEET exam. The position vector of a moving body at any instant of time is given like this. The magnitude and direction of velocity they are talking about. So what is the position vector? Position vector is 5t square I cap, 5t square I cap minus 5t j cap. And you want to talk about velocity vector. So velocity vector, we know that is dr vector by dt. So that is equal to derivative will be 10t I cap minus 5 j cap. So if you are interested in velocity vector at t equals to 2. So velocity vector at t equals to 2 means it is 10 into 2 I cap minus 5 j cap. So that is 20 I cap minus 5 j cap. So if they are asking you the magnitude of V, so it is under root of 20 ka square plus minus 5 ka square. So that will be root of 400 plus 25, like that. Okay, root of 400 plus 25. So if you can take 25 common, I think how many times you will get? 4 times 25 and 100, and 400 another 4 times. I think it is 16 plus 1. So it is 5 root 17 meter per second. 5 root 17 meter per second. This way you can get the magnitude. And they are asking you what is the angle tan inverse 4, tan inverse 4, tan inverse 4. So you can notice that 4 will be obtained only if you do 20 by 5, not 5 by 20. So if I try to see this vector, so if I try to locate it like this, then 20 I cap minus 5 j cap, 20 I cap, which means 20 in the forward direction minus 5 j cap. So it is going to be this vector here, 20 in I cap and minus 5 in j cap. Okay, 20 in I cap and minus 5 in j cap. So if you are trying to find out the angle with x axis, then that is tan inverse mod of Vy by Vx. Remember dear, with whichever axis you will take the angle, that component must be coming in the denominator. I repeat, with whichever axis you will take the angle, that component will be coming in the denominator. So that is tan inverse Vy by Vx. Vy by Vx is 5 by 20. So that is tan inverse 1 by 4, which you are not asking, which they are not asking. They are asking in terms of tan inverse 4. So if you try to get this angle here, 5y, so 5y will be equal to tan inverse, this time Vy component will be coming in the denominator. So that is equal to tan inverse 20 by 5. So that will be equal to tan inverse 4. Okay. But with which axis? This angle is made with negative y axis. with negative y-axis. So the velocity magnitude is 5 root 17, its direction is tan inverse 4 made with negative y-axis. So 5 root 17 tan inverse 4 negative y-axis. Third option is correct. Is that clear? So basic vector analysis as well as the derivative involved here. Is that fine? You can take a screenshot now. Just a moment. Yeah. Chaliye, let's move on to the next one. A ball of mass 100 gram is projected with velocity 20 meter per second at 60 degrees with horizontal. Let us see that diagrammatically, that there is the ball here, mass 100 gram they are telling, 100 gram mass, okay, m mass, let it be m mass, and it is thrown with a u velocity, let's say the angle is theta. The decrease in kinetic energy of the ball during the motion from point of projection to the highest point. From point of projection to the highest point h max. Okay, we know that at this point it will be moving with u cos theta like this. U cos theta like this. So from here to here, when they say decrease in kinetic energy, decrease in kinetic energy can also be said as conservation of energy here, increase in gravitational potential energy. Kinetic energy is decreased and there is no air drag. If there is no air drag, no heat dissipation, mechanical energy will be conserved. Whatever is the decrement in kinetic energy, the body will keep on slowing down. That will get converted into potential energy because body is getting attaining more and more height. So decrease in kinetic energy is increase in gravitational potential energy. It is given by mg h max. So that can be given by mg. H max value is u square sine square theta by 2g. Gg get cancelled. It is half mu square sine square theta. Also, alternatively, or you could have said like this, decrease in kinetic energy. Decrease is always initial minus final. Kinetic energy initial minus kinetic energy final. Kinetic energy initial is half mu square minus final kinetic energy means kinetic energy at the top, half mu cos theta ka square. So what you got is half mu square and it is 1 minus cos square theta, that is nothing but sine square theta. So half mu square sine square theta. So whether you apply the conservation of energy or you follow the definition of decrease, I mean the meaning of decrease, that is initial minus final, eventually you are going to get the same result, half mu square sine square theta. Now easily we can substitute the data here. So that is half. You need the answer in joules, so you are supposed to keep everything in SI units. 100 grams means 0.1 kg means 100 by 1000 and it is u square. U is how much? 20 ka square and it is sine square 60 degrees with the horizontal. So what you got is 1 by 2, this is 1 by 10, 20 ka square is 400 and this is root 3 by 2 here. Okay, I think you can solve it. You want me to solve? See, 1 0 1 0 is cancelled, 2 2 will cancel 4. It will be 10, 1.73 into 10, it is 17.3 like that. Aren't we getting the answer? Once again, let us check the data. Decrease in kinetic energy is increase in potential energy. What we are missing? Half mu square sine square theta. 60 degree with the horizontal. 60 degree with the horizontal. And if I take 30 degree, I don't know whether the options, you can just check the calculation here. Further can be done. But I think if I try to do a quick calculation, I am not matching with any result here. That's okay. Maybe the options are, a bit different because I have copied it from one of the online sources only. Maybe, but I hope the situation is clear to you how to talk about the conservation of energy. Decrease in kinetic energy means fall in kinetic energy, gain in potential energy. All right. Okay, let's move ahead. Next is, again, this is a JEE main problem. because it is not involving too much of maths but few one or two trigonometric identities, I expect that this type of problem can be repeated in the NEET. If not exactly this, a variation of this. So let us see. Two projectiles are fired with same initial speed with same point on the ground. One is 45 minus alpha, one is 45 plus alpha. What is special? So special about them, sir? They are complementary angles. Complementary angles. So I will say, if I write about them, 45 minus alpha and 45 plus alpha, complementary angles these are. If these are complementary angles, range for same speed as they are mentioning same initial speed, the range is going to be same. R1 is equal to R2. But if angle is lesser, vertical component of velocity will be lesser and horizontal will be naturally more. Since vertical component of velocity will be lesser, time and maximum height are also going to be lesser. T1 is less than T2 and Hmax1 is less than Hmax2. I can even show you that on a diagram, that we all know that at 45 degrees exactly, the range is going to be maximum. This is Rmax. But if you deviate some angle alpha less than 45 or some angle alpha greater than 45, then your range is going to be same. But as you can see, this is H2 and T2, it is higher, and for this one, this is H1 and T1, it is lesser, but the range from here to here, R1 is going to be equal to R2. Okay. So the complementary angle formula, range is going to be same, but the time and Hmax are going to be different. Now what they are asking is the ratio of the maximum height attained, So Hmax1 by Hmax2, Hmax1 is u square sine square, this angle is 45 minus alpha by 2g, by u square sine square 45 plus alpha by 2g. So you can see u square by 2g got cancelled. Sine square theta can be written as 1 minus cos 2 theta by 2. So 1 minus cos twice of 45 minus alpha by 2 by 1 minus cos twice of 45 plus alpha by 2. So now this 2 got cancelled. What you got here is 1 minus cos of 90 minus 2 alpha, and it is 1 minus cos of 90 plus 2 alpha. So cos of 90 minus something is the first quadrant. First quadrant mein cos will be positive. So it will be positive of cos 2 and 90 will change the name. 90 will also change the name. The cos will turn into sine. And here 1 minus 90 plus something means second quadrant. Second quadrant mein cos will become negative and 90 will change the name. Cos will turn into sine. So what you have is 1 minus sine 2 alpha by 1 plus sine 2 alpha. As you can see, numerator mein it is minus, denominator mein plus. So definitely this answer is less than 1. Why I am emphasizing on less than 1? You will find something interesting. See here first, 1 minus sine 2 alpha by 1 plus sine 2 alpha. Now see why I am emphasizing on that. If you see this ratio here, do you realize that just now I said that H1 is less than H2? Objective approach here. If H1 is less than H2, this ratio has to be less than 1. Means numerator value must be lesser than the denominator value. You can even eliminate few of the options. Few of the options can be eliminated, like numerator value has to be less than the denominator value. This option can be eliminated and this option can also be eliminated. As in these two options, numerator contains a positive and denominator contains a negative. I hope this logic is also true, because sometimes being students you might feel, sir, this big trigonometric, these many trigonometric identities we generally are not habitual to use. So, how to approach these type of problems in that case. So in that case, these type of problems, few options can be eliminated. So your probability of success, even if you are trying to make a smart guess, can be increased. Right? Quickly take the screenshot. Okay, let's move on to the next one. So answer is here already marked. Just I'll tell you the approach. A projectile is thrown with a velocity of 10 root 2 meter per second at an angle of 45 degrees. So let us visualize it. What is happening here? So at an angle of 45 degrees, 10 root 2, 45 degrees. What is so special about the 45 degrees? You will be getting the Rmax value. And if they ask the Rmax value, you can get it as u square by g, just revising the formula for you, although they are not asking you that. They are saying with horizontal, the interval between the moments when speed is root 125 is the interval between the moments when the speed is root 125. When speed is root 125, if Vnet is equal to root 125, then you can say Vnet square is equal to Vx square plus Vy square. And here I will say this Vx, I mean Ux, which will not change with time, that will be equal to Vx, and that will be equal to 10 root 2 cos 45 degrees, which means 10 meter per second. And here this Uy is also 10 meter per second, but this will change with time, changes with time. Okay. So basically, if you have Vnet square here as 125, Vx square as 10 cos square 100 plus Vy square. So if you notice, 125 minus 100 is 25, and 25's root is not only 5, it is plus minus 5. It is plus minus 5. So they are asking you two time instants. At one time instant, velocity will be plus root 5, and at another time instant, velocity will be minus 5, and they are asking you the time gap between them. So let us see here. I will say Vy is equal to Uy plus Ay into t. One time though you are talking about the plus 5. Plus 5 will be equal to plus 10. Uy is plus 10 plus g is minus 10 into t. Okay, t1 time instant. So I will say 5 minus 10 is basically, or exchange the sides. 10 t1 is equal to 5, 10 t1 is equal to 5, so t1 is equal to 0.5 seconds. And on the other hand, if you write it as minus 5 is equal to plus 10 into t, u plus at, so minus 10 into t2, so you will get this t2 as 10 plus 5, 15 by 10, I think it is 1.5 seconds. Therefore, if they are asking you the time gap between them, delta 2, that is t2 minus t1, 1.5 minus 0.5, and hence the answer is 1 second. Hence the answer is 1 second. So the correct option is 1 second, already marked in front of you. Interesting problem, hai na? That they are talking a very basic component of a projectile, and there is no NCERT formula which you can, applying which you can directly get this answer. But the kinematics involved is very, very easy. That ultimately, what are the two time instants for which the speed is something, which means in terms of velocity, one will be on the positive side and one will be on the negative side under the influence of gravity. They have asked you the gap between them. All right, take the screenshot now. Chaliye, let's move ahead. Next is the velocity of a boat. It's a river boat problem here. A river boat problem. Before we talk about the problem, a quick recap. Shortest time condition, minimum time condition. I will say minimum time condition. So in minimum time condition, three things I want you to remember. Then in shortest path condition, again three things I want you to remember. Okay. So minimum time condition mein, v vector velocity of boat must be perpendicular to the velocity of the river, because your intent is to cross the river at the earliest, and the time of crossing, which is minimum, that will be equal to w by v, and the drift in that case will be given by u into time of crossing, so that will be u into w by V or V naught. Okay, W by V naught. Right? Now shortest path condition mein you will say V naught must be greater than U. I mean the swimmer or boatman must be stronger in comparison to the velocity of the river, then only you can achieve the minimum drift condition or zero drift condition. Here the drift is minimum and the minimum drift value is 0, and here the time of crossing will be given by W by under root of V naught square minus U square, like that. So these are the things I want you to remember. River boat problem mein at least remember the formula. And then if we see the problem is the velocity of boat in the still water is 10, means V naught value is given to you as 10 meter per second. Okay. The velocity river flows with 6 meter per second here, 6 meter per second. So U value is 6 meter per second. What is the difference in times taken to cross the river in the shortest path and the shortest time? The width of the river is 80 meter. W is equal to 80 meters. What they are asking you is delta T. Delta will be T when X is minimum minus T when itself it is minimum. Time when the X is minimum and then the minimum time. So that will be equal to W by under root of V naught square minus U square minus W by V naught. Let us solve it here. I will say delta T will be equal to W, that is 80, by under root of 10 square minus 6 square, Pythagorean triplet 10, 6 and 8, minus W is 80 and here it is 10. So I will say 80 by 8 here will be 10 minus 80 by 10 is 8 and hence the answer is 2 seconds. 2 seconds, so 2 seconds is your correct option. Alright, so I want you to at least remember the formula for the rain umbrella, river boat. These are the common and easy type of models. It's just that if you make an issue out of it, no, it's a tough thing, this, that, then obviously things are tough. But if you keep it simple, things are going to be simple. You can take the screenshot here. Okay, let's move ahead. Next is a rain umbrella problem. When a man is standing, the raindrops appear to him falling at 60 degrees from the horizontal. So raindrops are actually coming at 60 degrees from the horizontal. 60 degrees from the horizontal. And okay, so this is velocity of rain. So this can be taken as VR cos 60 degrees and this can be taken as VR sin 60 degrees. Okay. Now what the observer is doing, from his front side means this is the situation. The man was standing here. This is the front side of the man. When he is traveling at a speed of 5 km per hour on a horizontal road, this is velocity of man and that is 5 km per hour. 5 km per hour. So naturally we are interested in, see in this topic, what do we see? We see velocity of rain with respect to man. Always in rain umbrella problem, this is the velocity in which we are interested in. Velocity of rain with respect to man, that can be always written as velocity of rain minus velocity of man. But sir, we don't like vector subtraction, we like vector addition. It's okay, you can take the subtraction as negative addition minus of velocity of man. Okay. So you see we are interested in V rain which is available for us and we are interested in minus V man. If we are interested in minus V man, can I do it like this, minus V man, which is nothing but equal to 5. So obviously this component, horizontal component, has become stronger. If the horizontal component has become stronger, the vector resultant will shift somewhere here. So this time it should make a lesser angle than 60 degree with horizontal. Now see what they are telling. When he is traveling at a speed of 5 km per hour, they appear to him falling at 30 degrees, which means what we are assuming is absolutely correct. Right? They are asking you, find the actual speed of the rain. Find the actual speed of the rain. So in this situation, can I say tan 30 degrees? Tan 30 degrees. Whenever you take the angle with x-axis, the x component must come in denominator. Whenever you take the angle with y-axis, y component must be coming in the denominator. Just now a few minutes back I said with whichever axis you make the angle, that component must be coming in denominator. So tan 30 is 1 by root 3. X component must be coming in the denominator. That is how much? 5 plus VR cos 60 degrees, that is root 3 by 2. And in the denominator, in the numerator, what you will be having is VR sin 60 degrees. Cos 60 is 1 by 2. Cos 60 is 1 by 2. And numerator mein VR sin 60 degrees is root 3 by 2. Root 3 by 2. So what you can do is cross multiply here. You got 5 plus VR by 2. And that will be equal to, if you multiply it over there, root 3 into root 3 by 2, that is 3 VR by 2. Okay. So it is 3 by 2 minus 1 by 2, that's nothing but 1. So from here, I suppose VR is coming as 5. VR is coming as 5, and that's what your answer is. C. Easy, no? So when you visualize the rain umbrella problem and when you learn the formula for the riverboat problem, things are going to be very easy. Let's take a screenshot. Okay, chaliye. Let's move ahead. So now I want you to understand that the moment you see this type of equation, r vector is equal to a cos omega t I cap plus sin omega t j cap, like this. Whenever you see this type of format, a has to be multiplied with both, or if a can be even 1, which means it is cos omega t I cap plus sin omega t j cap, or cos and sin interchanged. It doesn't matter. Every time this represents the equation of uniform circular motion. Uniform circular motion. How it is uniform circular motion UCM? I'll prove it for you. But now after that, I would expect you to understand and remember that whenever you see this equation, it is going to be uniform circular motion. Speed is constant. So in case of uniform circular motion, with respect to center, if I see there is the particle, the position vector is this, r vector. Position vector is this. Velocity vector is always tangential, assuming that suppose it is moving in the anti-clockwise, and acceleration vector is always radially inwards, the centripetal acceleration. So as you can see, the r vector and ac vector, are anti-parallel to each other, collinear and anti-parallel to each other. So you will say r vector cross ac vector is going to be a null vector. Condition for collinearity or parallel and anti-parallel. R vector and V vector are perpendicular to each other. If they are perpendicular to each other, their dot product is going to be 0. Their dot product is going to be 0. Some conditions I am writing. Number 1, number 2, number 3. Similarly, acceleration and velocity are also perpendicular. So velocity's dot product with acceleration is also 0. So these are some basic vector product properties which you can comment on the base for a uniform circular motion. And how it is coming as a uniform circular motion? I will say x is equal to a cos omega t and y is equal to a sin omega t. So here sin square omega t plus cos square omega t, we already know that it is equal to 1, which means from here x square by a square plus y square by a square is equal to 1, which is nothing but the general equation of a circle. So trajectory is definitely going to be a circular one. Alright, you can even prove omega square r. You can even, like, instead of doing this trajectory, what you could have done is differentiate it once, differentiate it another time, second time. So the acceleration will come out as minus of omega square r or v square by r, which can be said as centripetal acceleration, and that's also the way to declare it as a uniform circular motion. Fine. Now let us read the options. Path of the particle is a circle of radius 4 meter. What you can take out common from here is 4 sine, see it is omega t I cap 2 pi plus cos of omega t j cap. Okay. So path of particle is a circle of radius 4 meter. That is true. You have to identify the wrong one. So this is true. Okay. Radius is the a value which you can take common. Here you could take 4 common. Acceleration vector is along minus r vector. See, I have shown acceleration and r vector are opposite. So this is also true. Magnitude of the acceleration is v square by r. as it is a uniform circular motion, magnitude of acceleration is omega square r or v square by r. That is also true. Magnitude of the velocity of the particle is, since first three are true, I guess this must be false, but let us see how it is false. Okay, let us see how it is false. So can I say magnitude v is equal to r omega, the r value by comparison is 4, and omega value by comparison is the coefficient of t omega is 2 pi, and hence the answer is 8 pi and not 8. Answer of velocity is 8 pi meter per second, and the given data is 8. That's why it is false, and you had to choose the false one. Okay, especially in statement based problem, our first emphasis will be that we have to select whether the right option or the wrong option. All right. Okay, let us take the screenshot now. Chaliye. Now, a particle starting from rest moves in a circle of radius r. It attains a velocity v0 in the nth round. It's angular acceleration. They are asking you the angular acceleration. Angular acceleration is also related as with tangential one. The tangential acceleration is r alpha. So I can do it by two ways. Way one, I can use the linear kinematics ones first. Linear kinematics means if I say v square is equal to u square plus 2as, here a will be the tangential acceleration. V square is basically v naught ka square. Initial velocity it says starting from rest 0 square plus twice tangential acceleration they are asking you here. Tangential acceleration can be written as r into alpha. Angular acceleration they are asking, and displacement is n round. N rounds have been taken. So n into 2 pi r. See, basically in a circular motion, displacement is every time 0. But what I am doing is I am assuming that I have, straightened the entire path. I am observing the circular motion as a straight line motion. In that case, the distance and displacement will be same, and that is n into 2 pi r. N into 2 pi r. So what you got is v naught square is equal to 2 into 2, it is 4 pi r square alpha, I guess. So alpha will be equal to v naught square by 4 pi r square. V naught square by 4 pi r square. And n is also there, I guess. N was also there. N, so n into, so 4 pi n r square. V naught square by 4 pi n r square. I suppose first option is correct. I expect first is correct. Let us find out by way 2 here. In way 2, we can write angular acceleration alpha will be equal to omega final square minus omega initial square by 2 theta. Just angular kinematics. Omega initial is 0. Omega final is v naught by r, its square, and it is twice of n rounds. N rounds you have completed. So n into 2 pi. N into 2 pi. Hence the final answer is v naught square by 4n pi r square. V naught square by 4n pi r square. Again you got option 1. Is that clear? So whether you choose the angular kinematics or you do it by imagining it to be the object to be traveling in a straight line, in both ways you can get the result. You can take the screenshot now. All right. Next is a cyclist riding with a speed of 27 km per hour. As he approaches a circular turn on the road of radius 80 meter, he applies brakes and reduces his speed at constant rate of this one, which means what they are telling is that this is tangential acceleration. The net acceleration of the cyclist on the turn is, so this can be taken as instantaneous velocity. Centripetal acceleration is instantaneous velocity ka square by r. So instantaneous velocity is 27 into 5 by 18 ka square by r. R is 80 here, 80 here. You can calculate this. 80 value is given to you as 0.5 meter per second every second. So 80 value is equal to 0.50 meter per second in every second means 0.50 meter per second square. So a net value is finally going to be under root of AC square plus AT square. Okay. not engaging you right now in the calculation, I think you can easily do that. I hope you understood. What we did is, in a circular motion, let's say the particle is moving like this, so you can observe that there can be a centripetal acceleration like tangential acceleration like this. There can be a centripetal acceleration like this, which is also called as normal acceleration or radial acceleration. So its resultant can be somewhere here, a net. And if they are asking you the angle between velocity vector, net velocity or instantaneous velocity vector, and net acceleration vector, if they ask you the angle phi here, then here phi will be equal to tan inverse. Again the same logic, bacha, that with whichever axis the angle is made, that component must be coming in the denominator. So since you are trying to get the angle between net acceleration and net velocity, the tangential acceleration component must be coming in the denominator and centripetal acceleration component must be coming in the numerator. Alright, you see, individually you have obtained that in this question, and if they are asking you a net magnitude, then that will be under root of AC square plus AT square. So either they can ask you the direction or they can ask you the magnitude. In the said question, they have asked the magnitude and I have also told you how to get the direction. You can take the screenshot now. Hi dear, I can see few students are there. Right, I may not be engaging, getting engaged and busy too much in talking to you because there are too many problems which I want to deliver, and so that, in a hope that many questions can be repeated, if exactly not like data, but the similar models can be repeated in the upcoming NEET exam. So I'm just hoping and wishing you all the best to prepare along with this session and revising all the formula and the cases which we are discussing once the marathon is completed. Notes will also be provided to you. Okay, na? So don't mind if I don't reply you very soon, but let us keep learning. Chaliye, let's move on to the next one. A particle moves in a circular path such that its speed v varies with the distance. V equation is given to you and you have to find the acceleration of the particle after traversing a distance s. You have to find out the acceleration. But they are not mentioning which acceleration here. Find the acceleration. If not mentioned clearly, which acceleration, centripetal acceleration or tangential acceleration, we must calculate a net. Okay, so I'll follow the same thing. First of all, AC, centripetal acceleration, is V square by R, and R they are telling you, okay, all the four options are in terms of R. So V can be written as alpha root S ka square by R, which means alpha square S by R. Tangential acceleration is dV by dt if it is given as a function of time, or V dV by ds if that is given as a function of S. This time they are giving as a function of S. So V is alpha root S and it is d by ds of alpha root S. So this alpha will come common, alpha square root S, and d by ds of root S. Root x derivative is 1 by 2 root x, like that. So root S got cancelled. What you got is alpha square by 2. So if they are asking you finally a net value, that a net will be equal to under root of AC square plus AT square. So that is under root of alpha square S by R whole square plus alpha square by 2 whole square. So what you can get is alpha square outside the root, and it is under root of S square by R square plus 1 by 2 ka square means 1 by 4. S square by R square plus 1 by 4 and alpha square taken out. I think B is correct. You can also check the calculations. Okay, so what I did is, if they ask you centripetal, then you know the formula. If they ask you tangential, then also you know the formula. If it's a time function, do dV by dt. If it's a S function, displacement function, do V dV by ds. And this tangential acceleration only, it is actually R alpha, where alpha is angular acceleration. We have used this previously, or that can also be written as, this can also be written as omega square R. There are different formula. Choose which formula. But when they don't mention clearly which acceleration, then in circular motion you are supposed to calculate net acceleration. Alright, you can take the screenshot. Okay, let's move on to the next one. In the given figure, acceleration is 15 meter per second square. That represents the total acceleration. So just now I have shown you the figure. Where it is here. No, not here. Here I have shown it to you that net acceleration, centripetal acceleration and tangential acceleration, whatever I have explained here, we are going to use in this particular problem. So they say this A is going to be 15 meter per second square. So this component will be 15 cos 30 degrees and this component at this moment will be 15 sin 30 degrees. है ना? 15 cos 30 degrees, 15 sin 30 degrees, and what they are asking you, the speed of the particle. So centripetal acceleration depends on the speed, that is v square by r, where r is 2.5 given, and that is equal to the centripetal acceleration there, that is 15 cos 30 degrees. Okay, so from here v will be equal to under root of 15 cos 30 degrees is root 3 by 2, and you can also say it is 0.866, its value, just writing it out for you. So its value is 0.866, okay, and here it is 2.5. I think you can approximate the final answer. Okay, process is clear. Remember, NEET doesn't test your mathematical calculations. It is just an approximation one. Nearby you can choose. So the concept involved in this problem is that the net acceleration will be the resultant of the two, or you can say the individual of the two will be the component of the resultant. Means the same, no? Centripetal and tangential resulting into net, or centripetal and tangential are themselves the component of net acceleration. Both meaning is same, right? Take the screenshot. All right. Next is, yeah, that's a very important, very conceptual here, very conceptual problem. Read the problem once. So they are asking you that one end of string of length L is connected to a particle of mass m. This is m. And the other end is connected to a small peg on a smooth horizontal table. It is suppose fixed on a smooth horizontal table. This is the table, okay, and what is happening is if the particle moves in a circle with speed v, about this the particle starts moving in a circle, say with speed v, they are asking the net force on the particle directed towards the center, So when they say a net force, actually they are asking you only real forces. Remember guys, centripetal force is not a new force. Centripetal force is already existing force which is responsible to bind the particle towards the center. And centrifugal force is a pseudo force which is experienced by the particle which is moving in a circle. Okay, so first thing, centripetal force is what force, sir? Only tension. And where is centrifugal force, sir? It is experienced. It is not a real force. It is not observed. Okay, it is felt. So you will say that if the examiner is asking you how many forces are acting there, which means how many forces you can see acting there. Okay, so the only force acting on this block is tension here. Tension is the only force acting towards the center, and this tension serves as necessary centripetal force. So centripetal force is not a new force. It is already existing force or component of force or combination of forces. So serves as necessary centripetal force. All right. So the actual answer of this problem will be only T. No T plus mv square by r, no T minus mv square by r. The only force acting, only real force acting on it towards the center is T. and obviously the weight up and this normal reaction down will be balanced. And here I can show bending it a bit, that it is, moving it tangential path like that. All right, remember this problem here. Now let's move on to the next one. Okay, so now I have taken some slides this way that I will take it now as an opportunity to share some problems from my side, like what are the problems which I am expecting. Okay, so first of all, I'll take one problem model from the laws of motion regarding the pseudo force, block over the inclined, and that is a pseudo force thing. So I'll keep suggesting you few things. Every time proof will not be required, but whatever tips and tricks I'm sharing with you, do remember it. Okay, so the first thing is case 1. They are keeping a block over the wedge, angle phi, the wedge is smooth, the wedge or inclined plane has a mass m and it is mass m naught. Okay, and it is also placed over a smooth surface. You will say block is not, case 1 is block is not slipping over the wedge or inclined. Okay, and case 2, I'll do it parallelly so that you can compare and then remember. One by one you will keep forgetting here. Case 2, free fall of block. So again the same situation. This is phi, this is m, this is smooth, and this is m naught. Okay, so now first of all we will try to feel the situation here. What is happening? See, the block wanted to move down under the influence of gravity, but the wedge was serving as an obstacle, making it move in an inclined way, not in the vertically down way. Okay, so if by any chance you disappear the wedge, you remove the wedge, then the block will only start moving under the influence of gravity. That is only called as free fall. So if you are talking about the free fall, you want to remove the wedge. So acceleration should be provided in this direction, a naught. So acceleration should be provided in this direction so as to remove the wedge from below the block. You want to remove the wedge. So number one thing I want you to remember is what is the value of a naught over here? The value of a naught over here is g cot phi. G cot phi, we can even prove it. You can try proving it, but I will just share the standard results which I want you to remember. Okay, a naught is equal to g cot phi, and this is the acceleration of the wedge in horizontal direction. And acceleration of the block will be equal to g downward direction. That's why you are calling it a free fall. Okay. In that case, the required force to be applied, will be equal to mass of wedge into acceleration of the wedge, g cot phi, and that is required in the horizontal direction so as to remove it. And in that case, if they are asking you the contact force between the block and the wedge, since you have just removed it, there is no contact force, 0 Newton, no contact force here. If you talk about the same things in this case, then you will say block is not slipping over the wedge, which means this time you want block and wedge to move together, kind of sticking together and move together. So you are supposed to accelerate on this side. This is a naught. You are supposed to accelerate on this side, not to remove, but to make it stick, make it in contact. So here I would say that the value of acceleration a naught is equal to g tan phi, and that is equal to the acceleration of block, and that is equal to the acceleration of wedge. Why, sir? Because this time they are sticking together and moving together, which means both the acceleration will be same. So the required value of force is going to be equal to capital M plus m naught into the common acceleration with which they are moving, that is g tan phi. And in this case, the contact force between them, which is only the normal reaction, because of smooth surface there is no friction, that will be given by mg by cos phi, or that can be written as mg sec phi, mg secant phi. Okay, and if you can see here, if I modify it a bit, modified model, This time, if they place it over a table and they say that determine this m dash, determine the value of m dash such that the block of mass m naught doesn't slip over the wedge of mass capital M, all contact surfaces are smooth. All contact surfaces are smooth. This also and the wedge also, table also as well as the wedge, and they don't want any slipping, no slipping. We don't want any slipping. They are asking you the value of m dash such that the block doesn't slip over the wedge. So how to do it? You will say this must be moving with a common acceleration of g tan phi if this angle is phi over here, and this must also be moving with the same acceleration of g tan phi because string is inextensible. String is inextensible. So for the block, for the hanging block, I will write m dash g minus t, that is m dash into g tan phi. Okay, g tan phi. Remember, there are two variables now. The two variables are m dash and t, m dash and t. And for this combined system, for no slipping, sticking together and moving, you can write t will be equal to capital M plus m naught into g tan phi. Two variables. What are the variables? Variables are m dash and t. The two variables, two equations can be easily solved. Space nahi hai, I'm not solving it for you. I don't have space, but I'm guiding you. So I want you to take a screenshot. Remember that case 2. Remember this case 1, all the results, and remember the approach for solving this problem. Do it. All right. Hi Mohit. Hi others. Hi Chandu. Yeah, I can see you people are commenting, but I'm not in a, I'm not finding out that much time today to reply all, but yeah, hi and I welcome you all. Let us, continue with the problems. Time is limited till the NEET, so we'll keep talking after the NEET exam. Okay, chaliye, let's move on to the next one. Now, this time we will talk about the spring and Atwood machine. A bit we have already talked about pseudo force. Now we will focus on Atwood machine. Problem number 31. So this problem I dedicated for pseudo force model. Now I will dedicate for Atwood machine. Atwood machine. Now what is this Atwood machine model? So first of all, I'll talk about the standard Atwood machine. Ideal pulley, massless, frictionless. Massless and frictionless. This is M1. This is M2, and say M2 is greater than M1. So naturally this one will move down with a common acceleration. This one like A0, and this is moving up with A0. So here the tension will be equal to 2 M1 M2 G by M1 plus M2. So many times you would have done that. The common acceleration A0 will be equal to M2 minus M1 into G by M1 plus M2. And if they talk about the clamp reaction, force on the clamp reaction, then you can observe that here for the pulley, this is tension T, this is tension T. So this will be the force by the clamp. Force applied by the clamp on the pulley, force applied by the pulley on the clamp. Action reaction here, Newton's third law. So that is equal to 2T, and that is equal to 4 M1 M2 G by M1 plus M2. That is a simple one Atwood machine. Okay. What are the modifications? Modification number 1. Modification 1. They will talk about one mass greater than other mass. If M2 is greater than M1, then okay. So whenever one mass is greater than other, whenever one charge is greater than the other, so what you do the same what you generally do, means same formula, same equation, everything. Divide in the last step, divide the numerator and denominator with the bigger one. In the last step, divide the numerator and denominator with the bigger one. Then clamp reaction they are asking. Then force on the clamp. Okay, they are asking this. Or say then reading of spring. Reading or extension. Generally reading would refer to the force, but here let us say they are asking the extension in the spring. Situation is this, K naught. Here it is, let me take capital M and M naught. So this is M naught, and here it is capital M, which is greater than M naught. And they are asking you what is the extension produced in the spring. Okay, so how to do this problem? Step 1, I would say that spring force will be equal to the clamp force in the clamp, and that is equal to 2T. So that is equal to 4 M naught capital M into G by M naught plus capital M. And what did I say? Whenever this situation you see in physics, one bigger than the other, divide the numerator and denominator. Divide the numerator and denominator by bigger mass. Divide the numerator and denominator by bigger mass, that is capital M. So what you are going to get is F in spring, that we are going to get, if you divide the numerator and denominator, this is K naught into X, and that is equal to C. If you divide the numerator by capital M, it is 4 M naught G, and here it is M naught by capital M plus 1, where this M naught by capital M is almost negligible. So the value of X is equal to 4 M naught G by K naught. 4 M naught G by K naught. Okay, I hope that is understood to you. This is modification 1. Modification 2. Modification 2, if they relate to the center of mass motion in the same Atwood machine. Center of mass motion. See, this is, let me take some other data this time. This is M and this is 2M, okay, released from rest at t equals to 0. So first of all, what are the things examiner can ask you here? They can ask you the common acceleration of the block. The common acceleration of the block is m2 minus m1 into g by m1 plus m2. So that is equal to g by 3. I hope you agree with this. What other they can ask? Number 2, they can ask you the acceleration of center of mass vector. So you know it is m1 a1 vector plus m2 a2 vector by m1 plus m2. So that will be equal to m, and it is accelerated up. The lighter one will be accelerated up plus g by 3. Heavier one will be accelerated down by minus g by 3. That is the common acceleration. 2m minus m by 2m plus m, and it is m plus 2m. So it is minus g by 9. Why minus? Because under the influence of gravity, obviously the center of mass will be moving downward. Under the influence of gravity, obviously the center of mass will be moving downward. And if they ask the displacement or distance covered in by the center of mass, so it was starting like released, say from rest at t equal to 0. So it can be written as half gt square. So half into g by 9 into whatever time they say it's square. This is the way you can calculate that. And don't remember the data g by 9 because it is only obtained if the masses are 2m and m. If you change the mass or the pair of masses, definitely these things are going to change. All right. You can take the screenshot. It is a very informative slide again. Let's move on to the next one. Now we have to talk about another one. Like now we have talked about a bit of the spring model. We have talked about the pseudo force model. We have talked about the Atwood machine model. Let's talk about the conservation of momentum a bit. Okay, conservation of momentum based models. Conservation of momentum. Conservation of linear momentum models, in which particularly I will be talking about conservation of linear momentum. May say boat plus man. So it's a boat or a plank of mass capital M. Okay, there is a man standing at one corner of mass m naught, and initially the system is at rest. The man starts moving over the boat. For the man to move over the boat, the surface must be rough, but this friction will be an internal force here. So individually the momentum of man and boat will change because of this friction, But system's momentum will not change because there is no external force. In fact, the force offered by the liquid, as considering it to be a boat, is negligible. So external force acting on the system is 0. All right. Initially system is at rest. Now the man starts moving with the u relative velocity. Relative velocity of man with respect to boat is u. And now they are asking you what is the actual velocity of the man and the actual velocity of boat. It is a very common model, and whatever we will learn from here, we will see different modifications of that. So what I want you to understand here is we have to always take the opposite mass in this case. So velocity of man with respect to ground, I'll write for you. Just see how I'm writing it. And velocity of boat with respect to ground also, I'm writing for you. Let us see how. Okay. So velocity of man with respect to ground, if we have to write the velocity of man, always take opposite mass. Always take opposite mass. So if you have to write the velocity of man, since the man is moving forward, it should be plus. When you are writing the velocity of man, you should be taking the mass of boat. So that is capital M into u relative u by total mass of the system m naught plus capital M. Once again, velocity of boat with respect to ground, you will say if you are writing the velocity of boat, definitely it will experience a recoil. Recoil means it will move towards left. It's a vector, so minus. Always take the opposite mass. Velocity of boat, so mass of man into u relative by total mass of the system, that is m naught plus capital M. So always take the opposite mass, keeping the relative thing and plus minus sign into mind. Let us see what type of other models can come from here. Modification 1 or model 1. I will say that, common model, seashore model. Seashore model. This is a seashore, and there is a dog or a person standing here. Its initial separation is say x naught. Okay. And now the length of the boat is L. Fine. Whatever pattern you are applying for the velocities, the same pattern can be applied for distances also. This is L. And this man is of mass m naught and the boat mass is capital M. When man reaches the shore, reaches the other end, it starts moving like this. When man reaches the other end of boat, how far he is from the shore? How far he is from the shore? So final separation of man from shore. So you will write, sir, what was the initial separation? The initial separation is x naught. When the man is trying to move like this, it is coming near to the shore or away from the shore? Near to the shore. So separation must be subtracted. Now you want to write the displacement of man with respect to ground. But the issue is that man is not moving over the ground. Man is moving over the boat. So if the man is moving over the boat and you want to write its displacement with respect to ground, so always take the opposite mass. Once more dear, you are at this separation, you are coming closer. That's why you are doing minus here. Now you are writing the displacement of man. So you should be taking the mass of boat into account. So that is capital M into relative displacement over the boat. It has traveled L by m naught plus capital M. So this is the way you answer this. Another modification, modification 2. Suppose there is a wedge, this is phi, this is L length, this is m naught mass, this is capital M, okay. All the surfaces are smooth, all the surfaces are smooth here. No external force of friction, gravity will be acting definitely. So they are asking, when the ball or block here reaches the bottom of the wedge, when block reaches the bottom of wedge, how far bottom of wedge, how far both have displaced? how far both have displaced. See, when the block reaches the bottom of the wedge or on the ground, it is actually traveling L, but we can conserve the momentum only in the horizontal direction. Why so? Because vertical direction mein gravity is acting, so momentum will change. You can't conserve the momentum, you can't apply this shortcut. But in horizontal direction, there is no gravity or gravity component or any other force. We can conserve the momentum, so we can apply this shortcut. So displacement of wedge traveled in the horizontal direction, they are asking you what it is. So you will say always take the opposite mass. So opposite mass is how much? M naught. You are writing the displacement of wedge. So whose mass you will take? Block's mass, M naught, into relative displacement. But dear, this time the relative displacement must be written in the horizontal direction because you can conserve the momentum in the horizontal direction. That is L cos phi by total mass of the system, that is M naught plus capital M. Alright. Let us see another model, last model for this, then we can take the screenshot and move ahead. Model 3, man plus balloon or balloon rope model. This is the balloon of mass capital M. This is the ground light rope, and there is a man of mass M naught here. There is a man of mass M naught here. This is the length of the rope, and this is the height H naught initially. Okay. So man starts climbing over the rope. The rope is light. The rope mass is negligible, or you can say rope and balloon combined mass is capital M, like that. So the question is, when, here we can say when man climbs to the top of rope, when man climbs to the top of rope, you have to tell the height, final height of man as well as the final height of balloon. So H final of man, you will say the man was already having a height of H naught plus it will be having some more height which with respect to ground. But if you are writing the man's further height with respect to ground, whose mass is to be taken? Balloon's mass. So capital M into relative displacement that the man has travelled over the rope or the balloon into L by M naught plus capital M. Sir, in the previous question under the influence of gravity, you didn't conserve the momentum. In this question, even under the influence of gravity, how you are conserving the momentum? Because this time, or how you are applying the shortcut? Because this time the balloon was floating in the mid-air, which means the buoyant force was balancing the gravity. So gravity was there, but the buoyant was balancing the gravity, so the net force acting on the system was 0. ठीक है ना? Floating air. I should mention it over here. Floating balloon. Floating means buoyancy is balancing the gravity. And if they are asking height final of the balloon, then you will say balloon's original height was H naught plus L. Balloon's original height was H naught plus L, but now it will come down, minus of something. Now something is written for the balloon, so whose mass is to be taken? Man's mass, M naught into L by M naught plus capital M. So this slide I dedicated for the conservation of momentum and a very important model of the two particle system, seashore model, boat plus man model, wedge, block over the wedge model, balloon and rope model, all this for the conservation of momentum. Please take a screenshot. All right. Right. Make sure you also share these things with your friends. Okay. Now let us do some standard problems now. We will then get back. Yeah. Now a body of mass 5 kg is at rest. Now some models regarding the friction, then we'll again get back on the few more things which I want to share. A body of mass 5 kg is at rest on a horizontal table. The coefficient of friction is given to you as 0.6. A force of magnitude 10 Newton is acting on the block at an angle of 37 degrees from the horizontal. Then they are asking you the friction force acting between the block and the table will be friction force. Friction they are asking. So whenever they ask friction in the question, the first thing you need to check is whether that is a static friction, limiting friction or kinetic friction. Kinetic friction has a formula mu k into n. Limiting friction has a formula mu s into n. But static friction doesn't have a formula. It is self-adjustable in nature. So always equal to the external, the effort which is trying to make it move. So let me draw the free body diagram for you. So in this free body diagram, there will be definitely this W equals to mg. So mg is how much? It's 5 kg. Let us take g as 10. So 5 into 10 is equal to, we can have 50 newtons here. Okay. You can even take 9.8, right? Answer, because g value is not given to you, so you are supposed to take 9.8 only. But anyways, I'll just compare it. This is 10 Newton and this is 37 degrees. So this will be 10 cos 37. Cos 37 is 4 by 5. So it is 8 Newton here. And this is 10 sin 37. Sin 37 is 3 by 5. So it is 6 Newton here. Since this 6 Newton is not capable of uplifting it because the weight was 50, so there will be definitely a normal reaction or pressing force N or R in such a way that R plus 6 is 50, which means 50 minus 6, it is going to be 44 Newton. And because of this 8 Newton, there is a chance of slipping ahead, so friction must be acting back. But what friction it is, I don't know. I have to always compare with limiting friction. So first of all, I'll compare with limiting friction. The limiting friction value will come out as mu s into n. The value of mu is a single value mu given in the question, 0.6. Normal reaction 44. So you got 6 4s are 24 and 6 4 again 24. I think 26.4 Newton. This is limiting friction. Limiting friction 26.4 Newton. Limiting is 26.4 Newton, but it is not offered yet. We have to check whether limiting is offered, kinetic is offered or static is offered. I will say now here the F0 x value, which is 8 Newton, is less than the friction's limiting value, which is 26.4 Newton. So since you can't overcome the friction, you will not say that the body will move. So you will say body can't move. If the body can't move, that means the type of friction coming into the picture is static one. And what is so special about the static friction? It is self-adjustable. This friction is self-adjustable. Alright. So, therefore, the friction force self-adjustable, static in nature, is exactly equal to the effort applied, F0 into x. And that is equal to what? F0 x, because only 8 Newton force was trying to make it move, not capable to make it move. So the friction would be balancing it, and hence it is 8 Newtons. So limiting friction is 26.4, but actual offered friction is only 8, which was static in nature, no formula, a beautiful property of being self-adjusted. Okay, take the screenshot. All right, let us move on to the other one. So another very important problem, and one of the common problems which you have definitely seen just at the last time in order to emphasize on the property of the friction, its self-adjustable nature, this, that, I have taken it once again. A body of mass m is kept on a rough horizontal surface. There is a body of mass m, we have kept it over a rough horizontal surface. Coefficient of friction is given to you as mu. Single mu is given, so mu s, mu k, both are taken to be same. A person is trying to pull the body by applying a horizontal force, but the body is not moving. A person is trying to apply a horizontal force, but not moving. Not moving means that is, this F horizontal can vary from 0 to friction limiting value, because till the time you don't exceed the limiting friction value, you are not going to move the block. The force by the horizontal surface on the surface of the body is F. Force by the horizontal surface on the surface of body is F, means they are talking about the contact. They are talking about the contact force. Okay. So if they are talking about the contact force, this contact force value will be what? Or it will be minimum, maximum what? So capital F is equal to, like, I'll call this also as contact only. This also is F. So this is also as F and this is also as F. F contact you have to comment. So can I say it will again have a range here. How it will again have a range? F contact minimum value will be equal to under root of normal reaction N or R ka square plus friction's minimum value ka square, and friction minimum value being self-adjustable will be equal to the 0 Newton only. Like you don't push, you don't apply any force, it is going to be 0. So it is under root of mg ka square plus 0 ka square, so you will get it as mg. And friction contact force maximum value if you need, then you will be having under root of normal reaction will be still as it is, but this time friction's maximum value you need, and friction's maximum value for no motion, because they are saying it is not moving. So for no motion, friction's maximum value will be the limiting friction. So that will be equal to, let me keep it here. So that will be equal to under root of mg ka square plus mu mg ka whole square. So that will be mg and it is under root of 1 plus mu square. So this is the minimum value of the contact force and this is going to be the maximum value of the contact force. Okay, minimum value and maximum value. So the actual answer is that contact force will be greater than equal to this and less than equal to this. So C option is absolutely correct. I hope that's clear for us. Again, the self-adjustable property of the static friction. Take a screenshot. Okay, next. Okay, now let us talk a bit more about the momentum thing here. Momentum. Now, I think I have already shared these models. Yes. If I talk about the momentum part here, so I will say, see, it's a wall. As of now, my wall is at rest. Okay, for all the general cases. It's a very common mistake. Again, the students do it a lot. This is M mass. It is moving with U velocity. It hits here and perfectly elastic collision or rebounding. It moves, it comes back. So if they are asking you here change in speed, if they are asking change in speed, then change in speed is 0. If they are asking change in velocity magnitude, change in velocities, vectors magnitude, it is 2u, because it was going with you and coming with you. So speed is not changing, but the velocity being a vector has changed because the direction has changed. Similarly, if they are asking you change in kinetic energy being scalar, change in kinetic energy is 0. Because its speed is not changing here, but they are asking you change in momentum vectors magnitude, or you can also say impulse vectors magnitude, impulse vector. Then this impulse vector is going to be 2mu. Again, it is going with mu and coming with mu. So the change is the change in the direction. That's why it is 2mu. Okay, let's take 1-2 modifications in this. Modification 1, I will say that it is going like this, M moving with U, and the angle, languages, the angle made is phi. As of now, I am not changing the type of collision, I am just interested in talking about the momentum. So it is mu moving with phi, so you are going to get this, okay. So here I will be saying that definitely the final case will be that it turns back like this and moves here with the same u velocity and making this angle as u. So if someone is asking you, tell me the change in speed, the answer is 0. Change in velocity vector magnitude, so that will be, you will say which velocity vector has been changed here. This phi was made with the normal, so normal component will be u cos phi and parallel component will be u sin phi, but parallel component doesn't change. Parallel component to the wall will not change. Perpendicular component or normal component will bounce back. So it will be 2u cos theta. It is going to be 2u cos phi. If they are asking you the change in kinetic energy, the change in kinetic energy is again 0. But if they ask change in momentum vectors magnitude or impulse, that is going to be 2mu cos phi. Okay, if they give the angle is generally given with the normal, just like ray optics. But here, suppose if they say angle with the surface is made, this is normal, m mass, v velocity, this is also called as glancing angle is made with the surface, also called as glancing angle. Okay, and in that case again I am assuming that E is equal to 1, so definitely it will bounce back. Only thing that will change is the component. So you will say if it is made with the surface, so V parallel will be equal to V cos phi, which will not change, and V perpendicular to the wall will be V sin phi, which is going to be changed. Okay, this angle you can see again phi, alternate interior angles. So that will not change. So change in speed is 0. Change in velocity vector's magnitude because of the normal component, that will be 2V sin phi this time. Change in kinetic energy is 0, and change in linear momentum vector's magnitude, or you can say impulse vector's magnitude, that is 2mv sin phi. So it's a very simple model, but still I have seen a lot of people do some basic mistakes in this. I hope after this session you won't do the same. Okay, right. Let's move ahead. You can take the screenshot meanwhile. And now I am discussing some last model of the chain problem, which again is a very common model. Chain problem. You have seen it, and very common it is rough, having a coefficient of friction mu, and there is a chain kept over. That's a uniform chain. Mass m, length L, and they can ask you the portion, maximum portion that can hang, maximum fractional length that can hang, maximum percentage of length that can be hanging and not slipping from the table. What will be the work done in order to pull the entire chain over the table? So work done things we will start after a while, but regarding the force we can talk here. So suppose this is X, then the force which is trying to pull it down will be the hanging mass, that is total mass by total length into X into G. This force is trying to pull it down. So there is a chance of slipping of the chain, but on the chain there will be a friction acting back. If you are trying to get the limiting value of the friction, that will be mu into N. So mu into the load of the kept chain over the table, placed chain over the table. So that will be m by L into L minus X into G. Okay? So for maximum hanging length, the load will be exactly like overcoming the limiting friction. So you will say m by L into X into G will be equal to mu m by L into L minus X into G. So m by L into G got cancelled. X is equal to mu L minus X. So you will get X is equal to mu L minus mu X. Send this on this side, divide, so X will be equal to mu L by mu plus 1. This is the maximum hanging length. If they ask fractional length, then fractional length is given by X by L, that is equal to mu by mu plus 1. And if they are asking you the percentage hanging length, maximum percentage of the hanging length, then we all know that percentage hanging length will be given by fraction into 100, mu by mu plus 1 into 100. Alright, I hope that's clear for us. Okay, you can take the screenshot once again. Now, this completes the discussion of the models of the laws of motion, friction, and we will keep taking these. Very soon we will see circular motion, centripetal, centrifugal, like dynamics of circular motion. Kinematics of circular motion we have already seen. But now we will also see the dynamics of circular motion very soon. But in between, I'll start with the work, energy, power aspect. That is the next unit. Again, a good one and a simple one. So we'll talk about the problem models we are expecting from work we are expecting from energy, we are expecting from power. So if I say that, one problem from collisions is highly probable for us, one problem from spring is definitely going to come, one problem from vertical circular motion we can surely expect. So these are the domains from which we are going to discuss few more models now. These we have already discussed. And chalo, I'll take one by one all of them. So I will say spring mass model. Here, very important model, spring mass model, spring mass problems, and I'll also give you some shortcut regarding the same. So in spring mass problem, first model, I will give you, this is a block m0 mass coming with v0 velocity. Okay, let's take it after a while, coming with velocity. Let's take attached spring constant k0, and it is smooth over here. Okay, and you are applying constantly a force f0, a constant force here. Okay, a constant force here. What they are asking you is, what is the maximum compression in the spring? What is the maximum compression in the spring? What is the maximum velocity of the spring? And maximum velocity is always attained at x is equal to x max by 2. So that is equal to what? Okay, so I can derive it for you. There are different approaches for it. I will say way one is kinematics approach. Kinematics approach. Way 2 is your work energy power or conservation of energy, work energy theorem, work energy approach. And the third method is SHM approach. SHM approach, simple harmonic motion standard results, which we are going to discuss also. Okay, and the fourth method is my method. Okay, my method. Oh, I haven't introduced myself, I think, but many of you already know me. So my method, I'm just directly going to tell you the pattern here. When we say that, I'm not going to design any new physics, I'm just going to tell you that many questions in the exam can only be done pattern based. Every time I'm sharing the patterns. Okay, so x max is equal to twice of the responsible force for your motion by k0, the responsible force for your motion by k0, and Vmax will be the responsible force for your motion by under root of m0 k0. Okay, a responsible force for your motion by under root of m0 k0. I'll explain it to you how it is happening. For example, if I say this question, the spring force is not responsible for the motion of the block, the external force which is responsible acting on the spring block system there is that f0. So it is f0 by k0 and it is f0 by under root of m0 k0. But what if, sir, if I take it as rough having coefficient of friction mu? If rough having coefficient of friction mu, then number one, I will say x max will be equal to, now the force that is constantly acting responsible for your motion is f0 minus the kinetic friction, mu m0 g twice of f0 minus mu m0 g by k0. And the Vmax value you are going to get is f0 minus mu m0 g by under root of m0 k0. Okay, you can anyways verify by any of the methods. When I say my method, I am talking about the pattern based. Try to understand the pattern. So no need of applying too much of physics. You can directly keep writing all the results. For example, another example, let me take it as this method, this thing, that right now the spring is in its natural length. Right now the spring is in its natural length and this is block m0 and you are going to release it from here. You are going to release it from here. So if you release it suddenly, sudden release pe, block will oscillate. If block will oscillate, then during the oscillation you will say x max value. the x max value will be equal to twice of which force is externally acting on it for making it oscillate or move to m naught g. So the format is twice of m naught g by k naught, and the V max value will be equal to m naught g by under root of m naught k naught, and hence you are going to get it as g under root m naught by k naught. I hope that's clear for you. Okay, let us take another one. Okay, and in this case, if you don't have a sudden release, if you have a gradual release, then you will say body or block won't oscillate, block will not oscillate and moves slowly to attain equilibrium, and that equilibrium x naught is equal to x max by 2, because when you said that here velocity will be maximum, so velocity is maximum at mean position or equilibrium position. So at equilibrium position, the value of x is x max by 2. So instead of this twice of m naught g by k naught, if you do it half, 2 and half will cancel and you will have m naught g by k naught, all right. Let me introduce another model for you. So another example, a good one. Suppose this is a block of mass m naught. Let's make it rough also, and this is attached like this, and this angle is phi also, released, okay, suddenly. If it is released suddenly, then they can ask you x max and they can ask you V max. Okay, now see how I am writing these x max and V max. Here the value of x max will be equal to, now be very, very careful, twice of something by k naught it should be. Now what is that something? Which force is responsible to make it move or to make it oscillate externally apart from spring? So this is m naught g sine theta, but there will be a friction also happening there, that is mu mg cos theta. So I will take m naught g common and it will be sine theta minus or sine phi minus mu cos phi. Sine phi minus mu cos phi. And similarly, if you are writing this V max, you will be writing it as m naught g of this by under root m naught k naught. So you will be having g sine phi minus mu cos phi and under root of m naught by k naught. So this is the way you will get your final result. All right. Just see that carefully here. Copy it entirely. Take the screenshot quickly. So we are going to discuss, we are actually discussing category by category or category wise questions. So make sure you thoroughly revise all of them. There are high chance you will get directly any of these. Okay. All right. Let's move on to the next one. Problem number 38, problem model 38. I will say perfectly inelastic model, perfectly inelastic collision model and loss in energy models. So first of all, I'll take up again from the standard case. You know, M1 is moving with U1, M2 is moving with U2, U2 is naturally less than U1. Perfectly inelastic collision, E will be equal to 0. Bodies will stick together, M1 plus M2, and are going to move with a common velocity, V common. Okay, V common. So if they are asking you what will be the value of V common here, so V common will be equal to initial momentum, that is M1 U1 plus M2 U2. Why we are taking it as positive? Because momentum is a vector quantity, it is moving ahead. So all the positive forward vectors I will take it as positive. And it is V1 M1 plus M2. And if they are asking you the kinetic energy loss, which is not dissipated in the form of heat, but it is stored in the form of elastic potential energy, or you can say potential energy of deformation, because in perfectly inelastic collision there is some deformation in the bodies, that's why they are sticking together with the deformation. That will be equal to half mu initial relative velocity square, where mu is reduced mass. Half mu initial relative velocity square, where mu is reduced mass. So that will be equal to half m1 m2 by m1 plus m2, m1 m2 by m1 plus m2, and initial relative velocity is what? Initial relative velocity, you can see it is u1 minus u2 ka whole square. If they change the data mn to m or a numerical data, you can easily fit in there and then solve it. And you see, again we are talking about the pattern based thing. I'll take another example for you how it is pattern based. Suppose this time this m is moving with u and this 2m is moving with 2u, okay, and you have to see where they will move finally. So forward momentum is mu and backward momentum is 4mu. So obviously backward momentum will win, but still suppose we are assuming that they will stick together as 3m and move with the common velocity, then definitely this common velocity will come out to be negative. Why? Because as I said, the backward momentum is the winner. So here V common will be equal to positive of mu minus 2 into 2 4mu by total mass of the system, that is m plus 2m is 3m. So you can get something. And if someone is asking you the kinetic energy loss here, the kinetic energy loss is half reduced mass. Reduced mass is m into 2m by m plus 2m and initial relative velocity square. Initially both were moving opposite here, so initial relative velocity square will be 2u plus u, 3u's square. Okay, can be further calculated. Alright, this pattern of perfectly inelastic collision is not only applicable for our actual collision but also applicable for other models. Like 2 to 3 times I think you have got the disk rotation model in rotational motion. So I'm taking it here as another example. Okay, in this example I have taken this disk having moment of inertia I1 and another disk having moment of inertia I2, and say they are coaxially, already moving with omega 1, and say it is moving with omega 2. I hope you can sense the direction. Okay, and now it is gently placed. So finally, because of the intermediate friction in between, they will stick together and move. Okay, gently placed and finally moving with a common velocity. So this omega common finally will be equal to, you see, suppose anti-clockwise is taken as positive and clockwise is taken as negative. So it is I1 omega 1 minus I2 omega 2 by I1 plus I2. Okay, because the vector angular momentum conservation this time I am trying to apply, and kinetic energy loss because of the intermediate friction, if this time the kinetic energy will be lost, then I can say that that will dissipate into heat and that will be equal to half mu V relative square. So half, it is I1 I2 by I1 plus I2 and initial relative angular velocity. This time omega 1 and omega 2 are opposite. Opposite means their angular velocity must be added. So omega 1 plus omega 2 square. Omega 1 plus omega 2 square. Okay. Suppose we take the similar pattern in capacitors, capacitor, loss in energy. So you have seen this, question in the PYQs that initially these are the capacitors C and finally, okay, I think this I have taken differently. So there is another capacitor C, this is also C. Initially the position was at 1, finally the key was at position 1, finally the key will be turning to position 2. So what is this question exactly? That initially you have charged your first capacitor and now by the battery V0, now when you turn it to the second capacitor, the second capacitor was initially uncharged. So potential difference across it is 0 and across the first one is V0. If they ask loss in energy, again a NEET PYQ here, NEET PYQ. Loss in energy, people solve it entirely. I just say use the same pattern there. So loss in energy here will be equal to half C1 C2 by C1 plus C2. Why you can apply this pattern, sir? Because the way here finally the bodies are moving with same velocity. The way here finally the bodies are moving with same angular velocity. Similarly here the capacitors are finally going to attain the common potential. So half C into C by C plus C into initial relative potential square. Relative velocity square, relative angular velocity square, relative potential square. Relative potential is V naught plus minus 0 because the other one was not even charged. It's square. So it is C by 2 and hence the final answer is 1 by 4 CV naught square. Okay. So many things, I mean physics is a very beautiful subject here. Many things in physics are pattern based. You can just see them and answer them. Okay. Many things are going to be common. Alright. Quickly take the screenshot, then I'll take this discussion ahead with some more expected problems. Alright. Now, suppose there are again some problems here. If they say that determine this is a boat of mass capital M, it is a spring attached, there is a m naught mass here sent with some u velocity, and this time the surface is smooth, no friction, and here is the spring attached to the boat, and they are asking you determine the maximum compression in the spring. The question is determine the maximum compression in the spring. So I will say it's going to be very simple here. For maximum compression, for x to be maximum, can I say block and boat will move with common velocity, instantly at that instant, which means overall it is not the perfectly inelastic collision, but momentarily or for a moment that stage of inelastic collision will be attained. So in that case, I will say kinetic energy loss will be equal to spring potential energy gain. Kinetic energy loss is half, you will say for perfectly inelastic collision, m naught m by m naught plus m, and initially only one of them was moving, u plus minus 0 square, and spring potential energy gain is half k naught x max square. Okay, half and half can be cancelled, and I guess x max value will be equal to u square, and taking square root both sides it is u under root of m naught m by k naught m naught plus m, or you can also call it as u under root of mu reduced mass by k naught, where mu is the reduced mass. Alright. Similar example for attaining the perfectly inelastic collision stage at any one instant is, they are saying that this is capital M, this is smooth, this is also smooth, there is an m naught mass which started rising with u, and they are telling what maximum height it can attain. Here. Okay. So I will say that how I can solve it further. I will say here for h max, for h to be maximum, block should come at rest, not exactly, not absolutely, with respect to wedge, or you can say that is they have common velocity, they have v common at that instant. If they are moving with a common velocity at that instant, again I would say for that instant, so at least there is some loss in kinetic energy, no heat, so kinetic energy loss will be gravitational potential energy gain. Kinetic energy loss is half, again m naught m by m naught plus m, initial relative velocity u square, and that will be m naught g h max. So m naught got cancelled, and again you got the value of h max as mu square by 2g m naught plus capital M. Alright. So I hope you are understanding it, that how we are actually trying to relate the perfectly inelastic collision stage with many more models, many other topic and chapters of physics. Okay, that's what I call the beauty of physics. You read one chapter carefully, can be, you will understand many patterns and the behavior of nature, electricity, magnetism, mechanics, every time a similar analogous kind of behavior. Take the screenshot, then we will move ahead. All right. Till now we have done all the problems. Yes. Now let us move ahead with solving some more problems, and then I'll tell you few more models from my side. Okay. So let us keep a target of completing the 50 problems first of all in this phase 1. We have already set up a target of 100 good expected problem models. Now let's go on in the reverse order for a while. A tube of length L is completely filled with an incompressible liquid of mass M closed at both the ends. So you have a tube, the incompressible liquid is there, okay, incompressible, so it can act like a solid only, it cannot go anywhere, it cannot shift in any direction. The tube is then rotated in horizontal plane about one of its ends with angular velocity omega, okay. They are asking you the force exerted by the liquid at the other end. The mass is M, capital M, and the length from here to here is capital L. Fine. So now the thing is that they are asking what is the force on the other end. Way one of doing it is, because every element will experience a different force, so I will consider, because the radius is different, so at a distance of x, if I consider an element of width dx, okay, its mass is dm and it is going to rotate in this circle. So the force will be integration of all such centrifugal forces from 0 to L. So that will be equal to integration of dm omega square x 0 to L. Dm can be written as m by L dx into omega square x within limit 0 to L. So m omega square by L will come out, integration of x dx within limit 0 to L, so that is x square by 2. So m omega square by L, that's L square by 2 minus 0 square by 2, and finally you can say the force acting will be equal to m omega square L by 2. But as I know that being medical students, you people don't like integration thing and variation thing a lot, then we can have an alternative method also, the shortcut method. Centrifugal force is equal to m omega square r, a general formula. You can see that it is directly dependent on r, by which you can say it is a linear concept. So if it is a linear concept, the net force can be written as the effective centrifugal force. Linear concepts, and for linearity we can apply the center of mass concept. So that is equal to the entire mass can be supposed to be concentrated at the center. It is m omega square, and if it is concentrated at the center, the radius value will be L by 2, and see it is the same answer, m omega square L by 2, m omega square L by 2. So it is m omega square L by 2, option D. Is that clear? So whenever you don't want to use integration, just check whether it is satisfying linearity or not. If you want to skip integration on the basis of linearity, definitely you can apply COM approach. You can take the screenshot now. All right, let's move on to the previous one. A block of mass 10 kg, it's a kind of death well problem. You know death well problem? It's a block getting support against a rotating cylinder or rotating drum. A block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. So this is a hollow cylindrical drum. Radius is given to you as 1 meter, and there is a some block here. I'm maintaining some gap. This is 10 kg. This block is 10 kg, so the weight will be acting down mg, 10 and 10, that's 100 newtons here. Okay. The coefficient of friction between the block and the inner wall of the cylinder, mu value, is given to you as 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary. So in order to keep it stationary, definitely you are supposed to rotate like this omega. So relatively on this body, because its relative angular velocity will be omega, there will be a centrifugal force acting outwards experienced by it, that is m omega square r. So there will be a pressing, and hence you can say that their normal reaction N or R is equal to the centrifugal, and there will be a friction Fr limiting, Fr acting here, which will balance the weight. Okay, they are asking you the minimum angular velocity required. Minimum angular velocity required means you are referring to the limiting friction over there. Body is about to slip. So can I equate in the x-axis and y-axis? I will say in the x-axis, you will say n or r is equal to m omega square r radius, and in the y direction you will say Fr limiting, the weight should be less than equal to Fr limiting value for not slipping. The weight is mg should be less than equal to mu m omega square r. M and m can be cancelled, so omega is greater than equal to under root of g by mu r, or you can say omega minimum will be equal to under root of g, the value is 10, by mu, the value is 0.1 means 1 by 10, and the radius is 1. Denominator will 10 go into the numerator. It is 10 radian per second. 10 radian per second, option B. So this is the death well problem, that the body will be, because of the rotation, the body will have a pressing, will experience some pressing towards the walls, corresponding to which there will be a friction acting on the body, which will balance the weight of the body. Okay, take the screenshot. All right, let's move on to the previous one. Yeah, I have taken, this is a JEE Main January attempt of this year also, and the NCERT formula, this is the NCERT formula. This question simply teaches us whether you like or dislike a topic or a particular chapter, you must be thorough with all the NCERT formula given. Okay, so here I have taken it, and definitely I'll talk about the NCERT formula and its modification, minimum, maximum, everything. A car is negotiating a curve, they are asking you the maximum safe velocity. Maximum safe velocity, so that is given by under root of gr mu s plus tan theta by 1 minus mu s tan theta. This is the velocity. If they ask banking only, which means what is not there? Friction is not there, mu is 0. The moment you keep mu 0 here and here, so you get it as under root of, see, mu is 0 means this mu s is 0 here and this mu s is 0 here. So it is under root of gr tan theta. Gr tan theta. I hope you agree with the result. And if you say friction only, so if it is friction only, what is not there? Theta is not there, banking is not there. So this term and this term is gone. So what you can see over there is under root of mu rg. So under root of mu s rg. And instead of maximum value, if they ask minimum value, basic maths here, maximum mein the numerator is having positive and denominator is having negative. For the minimum value, you will observe that the sign will be again exactly opposite, no need to derive it. So it is under root of gr and it is tan theta minus mu s by 1 plus mu s tan theta. Okay. So I want you to remember all the NCERT formula here, standard maximum value formula, banking only, friction only, and in the same case if they ask minimum, just exchange the positive and negative in the numerator and denominator. Use common sense here, maximum ke liye numerator should be more, so positive there, denominator should be less. Minimum ke liye numerator should be less, so negative there, denominator should be more. Okay, let's move ahead. Okay, this we have done already. I hope no one is tired and we are doing it. Two billiard balls of the same size and mass are in contact on a billiard table. A third mass of same size. So first of all, let me draw the diagram here. Same mass, m and m, same size, are at rest. I am showing the top view. I am showing the top view of the billiard table. Okay, so no gravity and nothing, because gravity will be balanced by the normal reactions offered by the table. A third ball of the same size and mass strikes them symmetrically and remains at rest after the impact. So the third mass strikes them symmetrically means exactly in the middle, and finally this one is at rest. So due to the impact provided here, like this and like this, these two balls definitely start moving here, like this one and like this one, And I hope you understand that if you, like during the contact, if you join the center of all three, it will be forming an equilateral triangle. All balls are similar, right? If they are in physical contact, all of them, you join the centers of all, you will get an equilateral triangle over there. Okay. So what else I can see? They are asking coefficient of restitution between the balls. Coefficient of restitution between this blue colored and orange colored ball, although both are identical only. So how to find out? Coefficient of restitution is final velocity of separation by initial velocity of approach, okay, along the normal. Always it is applied along the normal, always applied along the normal here, okay. So what you can see here is finally, if it is striking and hitting the balls, initially there was only this one moving, but along the normal we have to resolve. So let me resolve it separately for you. Before or initially it was moving with u. So the common normal, let me draw it first. The common normal is this. So if this was u here, it will be having this angle 30 degrees because total angle will be 60 degrees. So along the normal, the velocity of approach is u cos 30 degrees. Okay. And finally, it is gaining some velocity like this v dash. But if I take this 30 degrees here, this v dash cos 30 degrees must be equal to u by 2. Now how's that, sir? How you can say it is equal to u by 2? So can I say initially only one body was moving in horizontal direction, and finally both the bodies are moving in the horizontal as well as vertically, in the x-axis, I should not say vertically but perpendicular to it. So if the two masses are moving, the mass has doubled, so obviously the velocity of both will become u by 2 and u by 2 like this. Is that fine? V dash cos 30 degrees is equal to u by 2 by conservation of linear momentum along the x-axis. So V dash will be equal to u by 2 cos 30 degrees. Okay. So the velocity of separation finally is V dash. So if you try to write it here along the normal, so I will say velocity of separation finally is V dash, which is u by 2 cos 30 degrees. And initially it was, I think, u cos 30 degrees along the common normal, u cos 30 degrees. So what you can see is u and u got cancelled. It is 1 by 2 cos square 30 degrees. Cos square 30 degrees is root 3 by 2 ka square. So what we can get is 1 2 will be cancelled. Remaining denominator 2 will come into the numerator, and root 3 ka square will become 3. So answer should be 2 by 3. Which option is 2 by 3? I think option B here is 2 by 3. E is equal to 2 by 3. Okay, so the important problem model here, important thing in this problem model was that basically we have the coefficient of restitution always applied along the common normal. You can't apply it in any direction. E must be applied along the common normal. That's the beauty of the problem. All right. Let's move on. Okay, few more models of work, energy and power we are going to discuss. So I'll start with the models of conservation of, I'll start with the model of vertical circular motion. First simple thing, that there is a block of mass m, something in the vertical circular motion, there is a block of mass m, length L, and it is released from rest. And suppose here it is making an angle theta, with horizontal, falling, by an angle theta. So at this moment, its velocity will be its tangential velocity like this, V tangential. They will be asking you how much it is. And one by one, let me talk about all the things. So first part, they can ask velocity. So can I say velocity tangential or net? That will be under root of 2gh difference. Say conservation of energy, or say conservation of energy, or third equation of motion, vertical if you try to apply. Conservation of energy will be a suitable logic here. So if this is phi, how much height you have already fallen? L sin phi. L sin phi you have already, or L sin theta you have falling down. So under root of 2g, the height difference created from there is L sin theta. L sine theta, under root of 2g L sine theta. At this moment, if they say, tell me the centripetal acceleration. So number 2, the centripetal acceleration will be equal to v square by r. So that is under root of, here it is 2g L sine theta by r is equal to L. So it will be 2g sine theta, I guess. Number 3, if they are asking you tangential acceleration, like this tangential acceleration, so I will say this is w equals to mg. If this angle is theta, then this angle will be again theta. So tangential acceleration will be equal to gravity's component over here, that is g cos theta. So tangential acceleration is g cos theta. If they are asking you the net acceleration, then a net will be under root of ac square plus at square. In vertical circular motion, I have obviously it is a circular motion here. So under root of ac square plus at square, so that will be equal to 2g sine theta ka whole square plus g cos theta ka whole square. So 1 sine square theta plus cos square theta will be 1. So it will be 4 sine square theta plus cos square theta. As you can see, one term of sine square theta plus cos square theta is 1 and the remaining will be 3 sine square theta. If instead of making the angle with horizontal, if we make the angle with vertical, then obviously every sine will change, every sine and every cos will be interchanged. Sine and cos will interchange. Rest of the things are exactly going to be same. You can take a screenshot now. Any one part, don't worry, NEET will not ask you everything. In NEET, there will be only one part or two parts that could be asked. Okay. Let's move on to the another one. Sometimes, see, in vertical circular motion, two things. Whenever you want to comment about the tension, it's a kind of force. Always draw free body diagram. And whenever you want to talk about the force, always draw the free body diagram. And whenever you want to talk about the relation, or you want to relate any two velocities, then always apply conservation of energy. Always apply conservation of energy to relate the velocities at two different points. For example, suppose we have this L length string, M mass bob, you are providing it some V naught, and we can observe it from here also. So if I talk about this situation, I will say there will be T max because there will be some centrifugal max that is equal to mv naught square by L, and there will be some W equals to mg also, correct? And if you try to get the free body diagram here, you will say there will be T minimum which will be supported by W, and that will be balancing the centrifugal force minimum, which will be equal to mv minimum ka square by L, where this m by L, the v minimum can be written as v max square minus 2g, the height difference between these two. The height difference between these two is 2L. Okay, so minus 2g into 2L. So what you have got the values of tension, centrifugals, everything at maximum as well as the minimum stage. So suppose, let me write it for you. If I am writing the T max for you, the T max here will be mg plus mv naught square by L, and let me write T minimum for you. T minimum will be T minimum will be T minimum plus W will be equal to centrifugal. So T minimum will be centrifugal minus W, mg minus mg, and what will be the centrifugal? Let's solve it further. So we have got here as V naught square, because it will be subtracted now, while bottom to top it will be subtracted, V naught square minus this. So what you have got is m by L V naught square, or just open the bracket here. So m V naught square by L minus m V naught square by L minus LL will get cancelled, 4 mg. Okay, so it is m V naught square by L minus 4 mg, and it is minus mg already there. So in this stage, if you do the minus, then you will realize that irrespective of the velocity, because mv naught square by L and mv naught square by L will be cancelled, Irrespective of the velocity exact value, the final answer will be mg minus 5 mg minus 5 mg, that will be equal to 6 mg. Okay. So these are some general relations and the case studies for work, energy, power. Till the time we have only talked about the conservation, vertical circular motion, conservation of energy in that, spring mass problem, momentum and mass, two particle system and all. Let us now emphasize on a bit on power as well as work energy theorem. Net work done is equal to change in kinetic energy. Take the screenshot. All right. Now, suppose for a body mass is equal to 2 kg, its velocity is given by 5x to the power 3 by 2. Okay, velocity is given by this. Determine the work done. Determine the work done in displacing the body. Determine the work done in displacing the body from x equals to 0 to x equals to 2 meters. Suppose that is the question, x equal to 0 to x equal to 2 meter. You see, v is given as a function of x and the x condition is automatically given to you. So what you can do is here, net work done is equal to change in kinetic energy. So that is equal to half m v square minus u square. So you will be getting it as half, the mass is given as 2 kg, v square is 5, x final is 2 to the power 3 by 2, but don't forget to take it square. Minus 5, 0 to the power 3 by 2, but don't forget to take it square, although this is going to be 0 only. So half into 2, which is nothing but 1 directly I can write, into 5 ka square is 25. 2 to the power 3 by 2 and its square, 2 and square, half and square power will cancel, 2 cube is 8. So 25 into 8, answer is 200 joules. Okay, 200 joules. So whenever velocity is given as a function of t or as a function of x, and examiner is asking you the amount of work done from one time to another time or from one position to another position, you can simply try to calculate the change in kinetic energy. Obviously, it is going to be equal to the net work done. All right, you can take the screenshot now. And I am taking the random expressions, but these are the questions which have recently come in the exam or different test series, or you can say in general. I'm emphasizing on these models again with a hope that if not exactly this expression, then something this way or that way with the powers or concept is going to be same. Okay. Concepts are always finite, problems can be any, a variety of types, but this type of model I am expecting in the exam. Okay. Now, let us talk something regarding the power. So, for the power, if I talk, interesting part about the power is, like I'm taking a question, power will be delivered only if you have the speed changing. Okay, you are doing some work, you are changing the kinetic energy, then only you can say that there has been a power delivered. So suppose they tell you that centripetal acceleration or normal or radial acceleration is given as k square rt square, and then they are asking you the power. So first of all, what is the job of centripetal acceleration? The job of centripetal acceleration is only to change the direction of the velocity vector, not to change the speed, not to change the magnitude, not to change the kinetic energy. So here the centripetal acceleration or centripetal force never delivers any power. So they are not asking you the power delivered by the centripetal force. No, they are not asking you the power delivered by, power delivered by centripetal or centrifugal. If they ask, the answer is 0. By centripetal or centrifugal, if they ask, the answer is 0. What they will be asking you is power delivered by the tangential force. They will be asking you the power delivered by tangential force. Okay. So how to tell that? Now see here, AC, which is equal to V square by R, that is equal to K square RT square. This implies V square is equal to K square R square T square, or V will be equal to KRT, correct? The tangential acceleration will be dV by dt, and that is equal to, the moment you will differentiate it, you will get Kr. Tangential force will be equal to mass into tangential acceleration, so that will be equal to mkr. Now that is this force who is responsible to deliver some power, because centripetal force, centrifugal force, their responsibility is to change the direction, not to change the speed, not to deliver any power. So here if I talk about the power, that will be equal to F tangential into velocity. So that will be equal to F tangential mkr, velocity will be krt. So what you have is mk square r square into t. Mk square r square into t. Power shows a linear variation with time. Power is showing a linear variation with time. Is that clear? So this was just an introduction of the power thing, so that before calculating directly the power, you must think that who is delivering the power. Till the time you don't, I mean, you can't apply this centripetal acceleration with mass and then you can't apply it with velocity. Please understand, centripetal acceleration or centripetal force, there is no associated power. The power will be associated with the tangential one. Okay, and examiner knows what is the common mistake students are doing. Fine. Chaliye, let's take, okay, please take the screenshot also. You can review that in the break time. After completing these 50 or half of the target, we will definitely take a break. I'll give you another video for the remaining problem models of the 11th class, and topic by topic we'll keep going, okay? We'll complete the entire target. Tomorrow at the same time, we will be having our 12th class, like modern physics, electrodynamics, same type of session. Now, suppose they are telling us that power is directly proportional to time. Power is given as directly proportional to time. You have to draw the graphs, like draw the variation of, draw VT graph and FT graph. Draw VT graph and FT graph. Okay, that is the question. So we will see here. First of all, power, which is dKE by dt, that is directly proportional to t. This implies d of kinetic energy half mv square, that is directly proportional to t dt. All right. If you integrate, this d will be gone. V square will be directly proportional to t square. V square will be directly proportional to t square, or V is directly proportional to t. V is directly proportional to t. So if V is directly proportional to t, the variation is going to be a straight line passing from the origin. Okay. Alternatively, you could have also said that if you want to write this power as F into V, that is directly proportional to t, which means m into acceleration dV by dt into V is directly proportional to t. This implies V dV, mass being constant, is directly proportional to t dt. V square is directly proportional to t, or V is directly proportional to t. Again, the same conclusion. Getting it? For power problems, these are the things which will keep on coming on your way. The deduction in a bit of calculus form. That's why in the starting of the session I told you, don't just try to skip the calculus dealing. And now they are asking about the force. Force is equal to ma is equal to m dV by dt, but V is directly proportional to t. So its derivative, it's linear, its derivative is going to be constant. This implies force is constant. If force is constant, its variation with time, you will say that it is going to be parallel to t-axis, not varying with time. Is that clear? All right, another power thing. So whenever they give you that, velocity varies with this power of s, acceleration varies with velocity, acceleration varies with s, power varies with time, all these questions must be dealt in this certain way. I hope you are clear with this. Okay. Take the screenshot. Right. Now, suppose I'll give you the work done thing here. Work done. Just a moment. Yeah. We have talked about energy. We have talked about, windmill model, right? the fluid flow and windmill model I'll talk about here. Suppose there is a liquid whose density is given to you as rho naught. Okay, very important model. Density, and it is common with, you know, momentum, force, energy, power, different chapters, similar model is there. Density rho naught, area of cross section is A, and the liquid is coming out with a velocity V naught here. Okay, so if I am asking you volume flow per second, this volume flow per second is basically volume flux. That volume flux is given by area of cross section into velocity with which it is coming out, AV naught. If they are asking you mass flow per second, so you'll multiply it with density, you'll get rho naught A V naught. Density into volume will give you mass, so density into volume flow per second will give you mass flow per second. If they ask momentum flow per second, the momentum flow per second, mass into velocity is momentum, mass flow per second into velocity will be momentum flow per second. So rho naught A V naught into another V naught, so you will be having rho naught A V naught square. And if they are asking kinetic energy flow per second, so kinetic energy flow per second is half, mass flow per second is rho naught A V naught into V naught square, kind of half mv square. So that is equal to half rho naught A V naught cube. So what do we understand by that? That suppose, like what is this volume flow per second? We call it as volume flux, will be used as a language in the question. What is this momentum flow per second? By Newton's second law, this momentum flow per second is force, Newton's second law. Okay, momentum flow per second is force. So this is the expression of force in the case of fluid flow, rho naught A V naught square. And if we particularly talk about kinetic energy flow per second, dke by dt, so this is nothing but power. Kinetic energy flow per second is power. Okay, which means suppose I talk about a windmill here, and you know, 3-blade or 4-blade windmill like this, and suppose the wind is coming with a velocity of V naught. Okay, wind is coming with a velocity of V naught. You say here power delivered is directly proportional to V naught cube. If V naught is made 2 times, doubled, then the power delivered or power developed will become 2 to the power 3 times. 2 to the power 3 times, that is, you will say power developed will be 8 times. So in short, if the velocity of wind is doubled, is made 10 times, the power delivered will become 10 to the power 3, 1000 times. It's very important and technical here. So, but for you, they won't be going into the windmill engineering or this or that, but you must understand in case of fluid flow, the power delivered depends on velocity to the power 3, velocity is q. Alright. So this is going to be a very important model. So I would suggest you to take its screenshot also and definitely revise it. Take the screenshot. Yes. Now let us talk about another, and as of now the left model which we have talked about here, which we are about to talk about the work here, finding the work done in case of block problems, finding the work done. So suppose the examiner is telling you that you have a rough surface here, mu s is equal to 0.5, mu k is equal to 0.2, take g is equal to 10 meter per second square, and mass is 5 kg. Okay, mass is 5 kg. So the force which you are applying, F naught, is equal to 100 Newton. Okay, force you are applying is 100 Newton. Examiner is asking you determine the work done by external force in first 2 seconds. Work done by external force in first 2 seconds. Okay, and also the velocity. Okay, that's it. I think remaining parts I will teach you while discussing the model. As I'm discussing all the modifications and everything, we will talk about it right now also. So let us draw the free body diagram here. This is 5 kg. This is 5 kg. The force which you have applied F naught is 100 newtons here. Okay, and the weight W is equal to 50 newtons. There will be a normal reaction definitely, and this normal reaction N or R is equal to 50 newtons here, and there will be a friction. So whenever we talk about the friction direction, we also talk about its magnitude. Suppose they talk about limiting friction value, that is mu s into n. So mu s into n is 0.5. It is 0.5 into normal reaction is 50, which means 25 Newton. And at the same time, we should find out Fk, that is mu k into n. So 0.2 into 50, so that is equal to 10 Newton here. Okay, I've just taken a random data for explaining it to you. Here, the F external, which is 100 Newton, is greater than the friction's limiting value, that is 25 Newton, which means the block will move. And if the block will move, see, the comparison is always done with limiting friction. But if the block is moving, the actual offered friction is not the limiting friction. So the friction offered this time will be kinetic. The friction offered this time is kinetic. Okay. And how much it will be, how much will be the friction and what will be the net acceleration, let us find out. Net acceleration is F external minus friction, which is kinetic in nature, by mass. So net force which you have applied is 100 minus, you compared it with limiting, but the friction offered is not limiting, it is kinetic, 10 by 5. So I think 100 minus 10 is 90, 90 by 5 there is 18 meter per second square. Please keep checking the calculation. Then you will say that force you have, acceleration you have, displacement you want, S is equal to ut plus half at square, 0 into 2, starting from rest assuming, plus half at square. Acceleration is 18 and t square is 2 square. So see, what you got is 2 will cancel 1, 2, 18 into remaining 2 is 36 meter. If they are asking you the work done, that will be external force, that will be equal to the external force of 100 Newton into 36 meter, and it is cos 0 degrees, Fs cos theta. So what you are getting it over here is plus 3600 joules. So a very simple question of calculation of work. I told you generally you can also calculate the work on the basis of change in kinetic energy. I'll do that here also. But this is another good problem model in which work done calculation is again based on the logic that comparison is always done with limiting friction, but limiting friction is not always offered. After comparison, you will decide whether static is offered, limiting is offered, or kinetic is offered. So before concluding the session for now, or taking a big break, before that, let me tell you another way of doing this problem. Way two of doing this problem is, you can say here, V, like net work done can be equal to, partially though you have to do the same, change in kinetic energy. So that is half m V square minus U square, where U is taken to be 0. So that can be taken as half. The mass is given as 5. The V can be written as 80. So 18 into 2, right? And it's, just a moment, V is equal to U plus 80, final velocity for 2 seconds, right? So 18 into 2 and its square you have. So I think now you can open it, you will get that, right? 2 ka square, 1, 2 and 1, 2 will be cancelled, then multiply it with 18. I think you will get that. So change in kinetic energy, you can again verify, you will get the same answer. Yeah, so finally we have completed the count. You can take the screenshot. Finally, we have completed the count of first 50 problems. We have started with the aim of doing 100 problems. Until here, we have already completed. I hope you enjoyed this session and you have had a learning experience till now. Take a break, have lunch, and make sure you revise everything. We'll get this part, the second part of this session in continuity. And tomorrow, at the same time in the morning, you are going to get the similar type of session for the 100 expected or must do problems of 12th class. All right. Thank you so much. All the best. See you soon. Bye bye.